Good afternoon, everyone. I, Dr. Sadhan K.Ghosh, on behalf of International Society of Sustainable Waste Management, Air and Water, ISWMAW, and its collaborators from Vietnam and India, welcome you all to this webinar. I will call the name of the co-organizers of the webinar today. United Nations Center of our Regional Development, UNCRD Japan, is our first co-organizer. Center for Sustainable Development and Resource Efficiency Management, Jadavpur University, India. CST, Indian Institute of Science, Bangalore, India. Hanoi University of Science and Technology, Vietnam. Institute of Strategy and Policy on Natural Resources and Environment, Vietnam. With this, I welcome you once again. I now hand over this to Dr. Sutripta Sarkar to proceed further.
Thank you, Dr. Sadhan K.Ghosh. And at the beginning itself, I would like to request all the participants to kindly put their mics in mute mode. Kindly put the microphone in the mute mode so that we can have a disturbance-free webinar. And when asked, please unmute. The speakers will be asked to unmute, and also you can put off your camera, but as and when you are introduced or during your presentation, you can put on your camera. So that makes it a lot more smoother. Thank you all, and thank you, Dr. Sadhan K.Ghosh. I, Dr. Sutripta Sarkar, welcome all the speakers, panelists, participants from various organizations to the Icon SWM's India-Vietnam Connect webinar, Circular Economy and Waste Management under Pandemic COVID-19. This webinar is the 5th pre-event of the 10th Icon SWM-CE. The next Icon SWM Asia and Pacific Connect webinar will be held on 30th September. I am now handing over the microphone to Nguyen Dak Quang, lecturer, Hanoi University of Science and Technology, Vietnam, to kindly proceed. Dr. Quang, please proceed.
Yes. Good afternoon, everyone. My name is Quang, and I come from Hanoi University of Science and Technology. So proud to be attending this conference. Against the backdrop of escalating pandemic COVID-19, which is origin from China, we feel it is our duty and responsibility to extend our support and care to common people who are facing difficulty in everyday living, staying far from the heart of the city and disconnected from regular communication in this trying time. The objective of the webinar is to discuss the waste management issues and challenges related to the protection of people and the environment from the effect of COVID-19, as well as the resource circulation that is taking place in these two collaborating countries, India and Vietnam. We are very glad to announce that there are more than 350 participants from 10 countries have registered and participating in the webinar through the webinar platform and Facebook live streaming of ISWMAW and our collaborating organization. We are pleased to inform you that we have a group of very distinguished expert speakers and panelists in this webinar. I'd like to inform that all of the participants who have registered and attending the webinar through the GoToMeeting and Facebook live streaming will be given certificate of attendance as per our database. I'd like to cordially invite you, all the participants, to submit article and join the 10 Icon SWM-CE conference on virtual platform. The 10th International Conference on Sustainable Waste Management towards Circular Economy to be held during December 2 to 4, 2020 at Kolkata, India. Submission date of full article is 30 of October 2020, and the detail of which will be sent to you and already available in www.iswmaw.com. Once again, I would like to note that it is important for you, all of the participants in the webinar, to remain in the default mute mode. Speaker will unmute only when requested. The question and query may be asked only in the chat box for the specific speaker or panelists, which will be handled by our reporter and coordinator. I request the camera may be put on, else it will be off. Now, I'm pleased to invite Professor Sadhan K.Ghosh for delivering the opening speech from India. But before, let me introduce Professor Ghosh. Professor Sadhan K.Ghosh is a professor in mechanical engineering and the fellowship coordinator of the Center of Sustainable Development and Resource Efficiency Management, Zadap University. He served as the Dean, Faculty of Engineering and Technology, and Head of Mechanical Engineering, and the Director of CBWE, Ministry of Labor and Environmental, Government of India and Industry. He is internationally renowned personality in the field of waste management, circular economy, green manufacturing, supply chain management, and co-processing of waste, plastic waste and e-waste management, recycling, ISO standards, and TQM. Professor Ghosh is the president of ISWMAW and the chairman of the Consortium of Research in the International Collaboration CRIC. He received several awards and patents. He wrote already 9 books, 14 edits volumes, nearly 220 national and international articles and chapters. He is the associate editor of the International Journal of Material Cycle and Waste Management. He is the consultant and international expert of UNCRD, DESA, APO, Japan, China Productivity Council, SASEF, Sri Lanka, IGES, Japan. He was a convener of ISO TC 61WG2, a member in the Indian Minor Committee of ISO TC 207 and ISO TC 275. He has been instrumental to the ICON SWM movement worldwide and involved in collaborative research with 14 countries for the last 3 decades. Now, I invite Professor Ghosh to kindly unmute and deliver the opening speech. Professor.
Thank you, Kwang. I request all other participants to kindly mute your microphone, otherwise there is a noise coming. I request all the participants to please mute your microphone. Thank you very much. I am really pleased to see quite a good number, around 350 people from different countries, around 10 to 12 countries who is joining today. And I am very happy that one of my mentor on quality management and environmental management, Mr. Ashish Mukherjee, who was the chairman and managing director of FLACT India Limited and many other organizations in different capacities, is present here today.
Thank you,
And
Sadhan.
thank you, thank you. And on the other hand, I like to thank my counterparts in Vietnam for collaboration in the program. I express my heartfelt gratitude to UNCRD, Mr. C.R.C. Mohanty, for his support and acting as a collaborator. And you know that all these programs, which are Icon SWM India connecting other countries, are the pre-event of 10th International Conference on Sustainable Waste Management towards Circular Economy that will be held in December. And also, this is a pre-event of the Regional 3R Forum in Asia and the Pacific. So, with all this, I must thank all the participants for their presence during this program of today. Today, I will just speak on what is happening in India with respect to the circular economy implementation is concerned. But before that, as this is a program on COVID, I must remind all the people, including reminding me, that today we are passing through a very, very severe global tragedy. Hundreds and thousands of people died, healthcare system is sparkling, industries are paralyzed, and millions of people who are at their very, very bad stage with respect to the livelihood earning. And at this
Excuse me, sir.
stage,
Please
yes,
make your presentation full screen, sir.
but this is full screen. It is showing full screen to me. Yeah, this is full screen showing. So in that way, we must be very careful about the situation. On the other hand, we must not act over for tackling this situation. Like my friend, I was discussing with one of my friends from IISc Bangalore, that the waste management, we are focusing much on the waste and also the waste speakers, but we don't have any idea. And whenever you go to interview them, you will find hardly a very few people who are affected, who are the waste speakers. But on the other hand, if you go to the big housing society or others, you will find more number of people who are affected. So in that way, we must be very careful about what action to be taken, what action is needed, and how to go about. However, taking all this in hand, we must take an oath to identify and destroy the sources. Those are responsible for this pandemic disaster for the whole world. So now I'll come to the circular economy in India. What we are doing, the first thing, and I feel proud by saying this, that previously our situation was this, that we had number of waste dumping here, a very few SLF. But today, for last few years, people are taking oath in group, en masse, that we have to make our situation, we have to make our country cleaner, and we have to contribute towards the waste management, national resource efficiency. So these are the positive sign which is going positive towards the circular economy implementation. This is the support of the people and support of the government. And to say a few words on here, that we must sincerely thank the government today, that the inclusion of two very, very important scheme. One is the Swachh Bharat scheme, Swachh Bharat movement mission, and the other is insertion of 6 waste management rules totally revised in 2016. These two are a big issue and push towards the circular economy in our country. You know that today the resource efficiency of our country is not very high. If you consider the resource extraction, then we are at the 3rd largest material demand country. On the other hand, our productivity, material productivity is very low with respect to the global average. We have to consider that 17% of the global population are in India, but we have only 2% of the global landmass and 4% of the total freshwater resources. So these are all challenging issues in India. But similarly, case, we are recycling only 20 to 25%. If you consider last 2 years, the recycling rate in India has enormously increased. I'll tell you what is the reason behind it. And it is the recycling rate is now nearly 35%. What are the policy? Because in any country, unless and otherwise there is a support from the government, circular economy implementation becomes a very, very big challenge. But in India, for a couple of years, we have been observing that there is a trend, there is a support by the government towards implementation of the circular economy and 5R. We started our journey in 1972 with the Stockholm Conference, and then the amendment of our the 42nd Amendment of Article 42 in our Constitution. So these two gave us a big impetus towards the environmental protection, as well as, of course, circular economy was not there in practice, but in thought process, it was always there, not in circular economy name, but in other name. So, and after this, we had number of supporting legislation in our country. One of the very important legislation is National Manufacturing Policy, which was adopted in 2011. The other one was National Design Policy 2007, and number of waste management policies, policy on electronics, policy on manufacturing, labeling, energy auditing, and many more. But the very important aspect of our policy instruments are, in 2016, as I told, that number of waste management policies adopted, and the last venture was in 2019, where the National Resource Efficiency Policy draft was released. Of course, we are waiting for a final policy on national resource efficiency. I'll show you what are the targets we have taken, which suppose the circular economy model. And in that, we have taken all the areas of concern, like ELV, end of life of vehicle, electronic waste management, EPR implementation, plastic waste management, marine littering, and of course, the associated and municipal waste management. We have, the biogas is one of the technology which we have been in India using for quite a long time. Lakhs of small and micro biogas plants are available in India, but in a more structured manner, we have in some of our states, there are concerted effort in the implementation of biogas plant, or rather biomethanation plant, waste to energy plant, though the waste to energy plant in incineration part is very low, but other waste to energy plant is higher. And RDF is a new addition into our resource efficiency venture, refuse derived fuel, and we have also formulated one national standard for RDF so that this can go to the co-processing. This program I have specifically designed for co-processing. Two co-processing presentation from two cement plant will be given in the technical session, and we can see that what is happening in India with respect to the co-processing. Because co-processing, in my opinion, co-processing is one of the best technology for waste treatment, because in co-processing, if you put the waste, there is no byproduct as waste comes out. So 100% of the utilization of the waste in the co-processing plant. We have number of ventures, we have number of recycling plants throughout India for the hazardous waste treatment facility. And I'm really enchanted to show you one of the photographs in a plant in Ghaziabad. This is a biomedical waste management facility. And you know that the reflection of the people and the plants are on the floor. So this is the level of cleanliness in the biomedical facility in India, which we have achieved. But what is the baseline? The baseline is not the expanded recycling industry, but we have to go for the source reduction, extended use, reuse, and as a matter of fact, we should work on the upstream measures, not the downstream focus. So this is one of the issue for each of the processes in India, which we are taking care for implementation of the circular economy. Now I am focusing on one area only. You know that in 2016, the government of India implemented the rules, and as well as 2014, we have implemented one, the Swachh Bharat mission. And we have taken a target that in 5 years, quite a number of cities in India have to work on circular economy, resource efficiency, and sanitation and cleanliness. In that way, we have the measuring tool for the performance. So in 2016, we started with 73 cities with only the physical progress, how the waste management work is going on, how much is the collection, how much is the processing, and all these things. And in 2017, we included around 434 cities throughout the country, and the focus was only the output parameter. And accordingly, 2018, 19, 20, 21, if you look into it, the number of cities has increased. In 2020, we could include 4,242 cities. It is quite a big number in our country. And the focus is changing from outcomes to sustainability, then institutionalizing the Swachhata. Swachhata means the cleanliness. And then for 2021, we have already targeted the integrated approach of the waste management and recirculation of the resources. So this is, and many of the cities are coming out as the best performers and throughout the country. So in that way, there are a number of technologies which we are using. We are having a focus that previously our focus was, or the tradition is, use the material and dump it. But today, our focus is use the material with the resource consumption, rationed resource consumption, that is, consume lesser material with higher productivity, and whatever is at the end of the pipe of a particular product, at the end of its lifetime, you try so that that material can be used as a resources in the as an input in the second material. And this is the concept of circular economy, and all through the country we are now trying, and there are a number of initiatives in each of the cities, each of the states, each of the Indian territory, where you will find many of the examples of this technology implementation. We are very efficient in the battery management, and we started from the 80s, the battery management, and today, excepting the very small batteries, we have the take back policy for all the batteries which anybody is using. So the last point which I like to Swachh Sarvekshan 2021, we started from 2016, and you know that this is the tool which rates the whole of the country with respect to a number of parameters, with giving some total marks. And on the basis of that, it is citizens' voice, service level progress, certification, and direct observation, and all the processes which they are integrating. And you know that there are a number of processes. I have just shown the photographs. The FSTP is one of the new areas where India has taken care of. Segregation of the waste, that is the main thing which is taken care of in all the cities, which 4,242 cities. And you know that if waste is segregated, any types of waste, then the implementation of circular economy is easier. But on the other hand, we have to be very much technology savvy, that whenever you are thinking at the conceptual level, you must think and you have to design the process as well as the material in such a fashion that the recirculation or the recyclability of the material is increased as the time progress, as the life cycle is going to the end. So these are some of the activities, and some of the photographs I have taken from Indore city, which has taken its first position throughout all consecutive 4 years in this survey. This is the situation in some of the cities where the MRF, material recovery facilities, are implemented. This is a waste to energy plant. We have around 4 or 5 waste to energy plant in the country, but we have number of facilities of composting as well as the biogas plant. Today we have number of, there are discussion on biogas plant, and you know that I'll not go into this detail, but these are the targets in the National Resource Efficiency Policy. We have numbers in all the cases, and you know that the implementation of such survection gave us one more advantage is today, if you want the data of yesterday, you will get all the data throughout the country. Any city, you will get the data of all the waste management facilities and what is happening, what is the process, what is the co-processing and everything. So these are some of the points which I like to highlight today with respect to the implementation of circular economy is concerned. But you know that we are working to use lighter material with extended life. We are trying to reduce the consumption of energy in the processes. Today in India, there is a huge target of implementation of renewable energy sources than the coal. Our thermal plants, power plants are now starving because there is a huge plan for implementation of the renewable resource using the renewable energy. So we are reducing manual intervention, the more structured manufacturing process, reduction of packaging, and one more important thing which I like to highlight, that we are ending the life use of single-use plastic material by 2022. So with this, I like to request all the participants here to please make your research in circular economy area. And the second thing, you try to imbibe the resource circulation and circular economy thought process into your country, into your processes. Each of the processes need a circular economy implementation so that the resource efficiency of the whole country is increased. And we have taken India and Vietnam together today because you know that India is doing very good, but Vietnam is also performing very well with respect to the resource efficiency and the implementation of waste management is concerned. With this, I thank all of you for your patient hearing, and thank you very much. Handing over the microphone to the organizer.
Thank you very much, Professor Ghosh, for the opening speech. That considering vulnerable area of society and the environment, especially the plastic burden now of COVID-19. Now, I'm pleased to invite Dr. Nguyễn Trung Thắng to kindly deliver opening speech from Vietnam side. Before I hand over the microphone, I would like to introduce Dr. Trung Thắng. Dr. Nguyễn Trung Thắng got his PhD degree in Chemical Technology from Sofia University of Chemical Technology, Bulgaria. He is the Deputy Director General of the Institute of Strategy and Policy on NATO. Resource and Environment, ISWMAW, a think tank that belongs to the Ministry of Natural Resources and Environment, MONRE of Vietnam. He has a 15 years experience in study and research and development of strategy and policy on environmental protection and climate change. His expertise focus on pollution control, waste management, sustainable production, and consumption. He participates actively in development of the National Strategy of Environmental Protection to 2020, Party Resolution 24, and PTW on proactive responding to climate change, strengthening natural resource management and environmental protection. He was also a coordinating lab author, CLA, of the UNEP Global Environmental Outlook 6, Regional Assessment of Asia Pacific, and participate in some joint research, such as the state of 3R in Asia and the Pacific, 2018, under UNCRD, and I guess Eco-Innovation and Sustainable Consumption and Production in Vietnam, and Sadhan Foundation, ASEIC, GEO6, Industry in Asia and Pacific, under UNEP and I guess 2019, Sustainable Waste Management Challenges in Developing Country, IHI 2019, and Waste Management and Plastic Consumption and Production in Vietnam, ASEIC 2019. Dr. Thang, kindly unmute, and the floor is yours now.
Thank you very much, Dr. Quang. Good afternoon, Professor Sadhan Ghosh, Mr. Mohamty, friends and colleagues. On behalf of the Institute of Strategy and Policy on Natural Resources and Environment of Vietnam, I would like to express our sincere thanks to the Jadavpur University, the Indian Institute of Science, the UNCRD, and the Hanoi University of Science and Technology for co-organizing this webinar. The COVID-19 pandemic is creating many negative effects and challenges to all aspects of our life. COVID-19 pandemic reminds us that human hand is linked closely to the hand of the planet. The response process to the pandemic recently is creating new waste that need to be managed, especially the medical waste. However, it also brings opportunities to change our way of working, such as online, as we are doing at the moment. It is also an opportunity to redefine the position of the human beings and the nature, offer solutions to restructure investment channels, trade flows, and modes of consumption towards more sustainable life. The efforts of international community to respond to the challenges of resource depletion, environmental degradation and pollution, and the impact of climate change have been recently demonstrated through various initiatives, including green economy, blue economy, low carbon economy, and circular economy. The circular economy is an economic model in which the process of design, production, consumption activities, and services has the same purpose to minimize material exploitation, extend product life cycle, reduce waste generation, and eliminate negative environment impacts. Transition to a circular economy brings more benefits for the implementation of the SDGs in the context of a serious crisis and climate change. Circular economy would reduce the impact to the nature to help keep the ecological balance, and so that to reduce the risk of environment-related disease in the future. Circular economy at the same time would promote a better waste management, including the medical waste, which is a consequence of the COVID-19 pandemic. In Vietnam, the rapid industrialization and urbanization process in recent years have been making serious problem of waste management. The waste is increasing, but the treatment facility infrastructure has not been developed adequately. The environmental pollution in urban and rural areas is getting more and more serious because garbage and wastewater have not been collected and treated. 70% of municipal solid waste are still landfill, mainly by the open dumping. Rural garbage has not been fully collected. Many unhygienic landfills cause soil and water pollution and block drainage system. Inappropriate combustion technology pollutes the air. Waste management regulations are ineffective. Policy tools, especially economic tools, are still weak. The market for environmental goods and services, environmentally friendly products, and recycled products are still underdeveloped. The social responsibility for businesses and people in compliance with the environmental laws in the production and consumption process is limited. Financial resources for the implementation law are insufficient and weak, not meeting the requirements. The environmental information, data, and sharing mechanism has not met the requirement for monitoring and evaluation the objective of the waste management and environmental protection. These are also the reasons that Vietnam is now actively in researching and institutionalizing the circular economy in our policy. Our institute, ISWMAW, has recently been tasked by the MONRE to conduct a study and to integrate circular economy into the national development strategy for the next 10 years. At the same time, we are now revising the law on environmental protection and trying to introduce regulations on implementation of circular economies. At the grounds, many typical models in the fields of plastic, paper, agriculture have taken steps to implement the circular economy development. And also the process of international integration with various free trade agreements such as CPTPP, Euro-Vietnam FTA, Europa-Vietnam FTA also provide opportunity for Vietnam to start the transition to a circular economy. However, realization of the circular economy in our country still face many challenges and difficulties. In this webinar, we expect to get more knowledge and experience from India and other countries, which will have further completing our circular economy development in Vietnam. I am very much impressed by the presentation of the Professor Ghosh with the result for development of circular economy in recent year in India. We would like to receive suggestions, particularly from scholars in this workshop, on policy solution, roadmaps, and priorities for Vietnam to successfully implement the transition to circular economy, promoting waste management in the context of the COVID-19 pandemic. With that, I would like to conclude my speech. Once again, we would like to express gratitude to the co-organizer of this webinar and look forward to a successful seminar. Thank you for your attention.
Thank you very much, Dr. Thang, for the wonderful opening speech. So kindly mute the microphone. I now request Dr. Payan Ghosh, Assistant Professor from SDG College, India, to proceed towards the technical section. Thank you.
Thank you, Dr. Kwon. I now request Professor Dipankar Chakraborty to chair the technical session, and I invite once again Dr. Trung Thang as co-chair of this session. But before starting the technical session, I want to introduce Professor Dipankar Chakraborty. Professor Dipankar Chakraborty is the professor and head of the Civil Engineering Department at Jadavpur University and also the university engineer. He is involved in research in wider areas of civil and structural engineering, having 67 publications in international journals and 101 publications in international conferences. He guided 8 PhD theses and 29 MTech theses. He is also involved in industrial consultancy. Now I request Professor Chakraborty and Dr. Trung Thang to proceed further. Thank you.
We are now proceeding to the technical session, and we have 6 eminent speakers in this session. Our first lead speaker is Mr. Mohanty from United Nations Center for Regional Development. I now request Dr. Nguyễn Đức Quảng to introduce Mr. CRC Mohanty.
So I would like to introduce Dr. Chaudhry Rudracharan Mohanty from Environment Program Coordinator, Experts, the UNCRD and UNDESA, responsible at UNCRD for implementation of 3 major initiatives and processes at regional and global level. First, promotion of environmentally sustainable transport, ESG, in Asia. Second, promotion of TRIA, resource efficiency and circular economy in Asia and the Pacific. And third, international partnership of expanding waste management service of local authorities, IPLA, a SDG partnership. Under this initiative, he played a significant role in establishing 2 high-level policy forums in Asia and the Pacific, Regional EST Forum in Asia, and Regional 3R Forum in Asia and the Pacific, and an international partnership on expanding waste management service of local authorities, IPLA. He worked in UNEP, RRC, AP. Now, I would like to request Dr. Mohanty to please unmute the microphone and share the screen for the speech.
Yes, thank you. Thank you, Honorable Chair. At the outset, on behalf of UNCRD, UN Department for Economic and Social Affairs, I would like to express our deep appreciation to International Society for Waste Management, Air and Water, and MONRE of Vietnam, and other organizations for organizing this
important webinar, the India and the Vietnam Connect in the context of circular economy and waste management. It is my great pleasure to see the colleagues from the Vietnam, Isponre. I think all of you know that Vietnam hosted the 4th Regional 3R Forum in Asia and Pacific, and my colleague here, my friend Dr. Thang, played a very crucial role in organizing this this forum in Vietnam in 2013 that paved the way for the adoption of the Hanoi 3R Declaration, which has 33 goals on 3R. So this is such a unique and the first regional declaration by the governments in Asia Pacific that paved the way for my colleagues from the Vietnam who played very instrumental role. All of you know that all UN member countries are concurrently and currently, of course, addressing and implementing a number of interlinked and mutually reinforcing international agendas, agreements, such as the 2030 Agenda, the SDGs, the New Urban Agenda, the Addis Ababa Action Agenda, which is looking for the new type of financing for building resilient societies and cities, Sendai Framework for Disaster Risk Reduction, and the Paris Climate Agreement. If we see actually the success of these international agendas and the agreements, it will largely depend on how effectively we are integrating actually circular economy in major development sectors, industries, SMEs, it may be construction, transport, industry, forestry, agriculture, water sector, etc. And also how effectively we address the circular economy that has also impact on the emergence of health issues such as the COVID-19 that we are talking about, and in that context, how we can actually build resilient societies and communities to face such emergencies. I think Professor Ghosh was talking about circular economy. Dr. Thang was also mentioned circular economy. We are certainly looking for an alternative economic model, which is not a conventional economic approach or linear economic model, which puts actually the resource efficiency in its center. And when we talk about circular economy, we are talking about that wastes are eliminated completely by treating them as valuable resources. That means nothing is waste. Everything has some sort of an economic value. And demand for raw material, energy, water, timber, minerals, other natural resources are minimized to the extent possible. Efficiency is improved, and at the same time, the pollution is minimized. Dr. Ghosh was mentioning, Professor Ghosh was mentioning about the Swachh Bharat mission, that very much, the foundation of it lies on how we can achieve the clean air, clean land, and the clean water. And circular economy plays a very pivotal role in achieving the Swachh Bharat mission. And circular economy also means we must decouple waste and natural resources, such as water, for example. And as you know, that water scarcity has hit 40% of the global population, and more than 2 billion people in the world face water crisis. And we cannot achieve any conceivable form of sustainable development without addressing actually water security. Unfortunately, today, if you see, many of the lifeline rivers and water bodies are severely polluted due to rampant discharge and dumping of the various untreated wastes. So what does it imply with regard to this COVID-19 situation? We are trying to address the climate change. We are trying to address the increasing frequency and magnitude of the natural disaster. At the same time, we have the new health emergencies like this COVID-19. So all these issues, emerging issues, are actually compounding the situation and making the situation extremely challenging to face the desired sustainable development goals. If we look at the same time the state of our oceans and their ecosystems, and you will find that each year around 8 million tons of plastics end up in our oceans, and at least 51 trillions of microplastics are already present in our oceans. And some studies say that by 2050, you will find actually more plastics than the fish in our oceans. And where do these plastics come from? There are studies that say that around 90% of these plastics into the oceans come from only 10 rivers in the world, and 8 are in Asia Pacific, and 2 rivers are in Africa. We should also note that for every 1 degree centigrade increase in the global temperature, an addition of 500 million people will face water scarcity. And in order to keep the average global temperature rise, that is above pre-industrial level, well below 2 degrees centigrade, that is what is envisaged under the Paris Climate Agreement, by end of this century, we need to also focus on renewable energy, circular economy, ecosystems, biodiversity, and sustainability, say sustainable transport system. And in order to operationalize circular economy or to move towards a zero waste society, we need a range of measures. I usually say them, these are like one pieces of a jigsaw puzzle. Like if you take out one piece, the whole system collapses. So what are these jigsaw puzzle pieces? Strong political will, the good governance, effective laws and legislations, strong institutions and institutional arrangements, interagency coordination. We are talking about the coordination between the Ministry of Environment, Ministry of Industry, Ministry of Urban Development, Ministry of Mining, or Ministry of Transport, Ministry of Energy, Ministry of Construction, and Ministry of Agriculture. Circular economy is a very cross-cutting, and we need the interagency coordination among all these 9 ministries. Access to technology, partnership, say for example, the public-private partnership, and also the triangular cooperation that I always emphasize. This is a systematic cooperation between the government, scientific and research community organizations, and the private and corporate sector, and 3R infrastructures. When I say 3R infrastructures, these are basically science park, theme parks, eco-industrial zones, where actually you see the waste of one industry is utilized as an input material, secondary raw material for another industry. So that goes on in the industrial symbiosis process. And currently, actually, we are in the era of 4th industrial revolution, that is people call Industry 4.0, which is a new digital industrial technology, that is digitization of manufacturing process, Internet of Things in manufacturing, to optimize the resource allocation and to achieve actually the ultimate resource efficiency. In order to propel circular economy, we need to address 3R as an economic industry. Actually, this was actually one of the themes of the Maldives 3R forum, where the countries agreed that 3R should be pursued as an economic industry. But this cannot happen in fortnight, without proper technology or without proper technological interventions. So when we talk about technological interventions, including the frontier technologies such as the IoT, the Internet of Things, 3D printing, robotics, nanotechnology, green chemistry, machine-to-machine interaction, cloud computing, etc. So the whole objective is how we can actually optimize the resource allocation, resource use in the manufacturing process to achieve the greater resource efficiency. But in reality, many of the least developed and developing countries do not have access to such frontier technologies. For example, a study that 18 ESCAP member countries, in 18 ESCAP member countries, only 2% people have access to ICT, information communication technology. So that means 98% people in those 18 ESCAP member countries do not have access to this information and communication technology. Therefore, it's extremely important to address the rising inequalities. When I say inequalities in access to the technologies, otherwise the least developed countries or developing countries will be further marginalized and pushed back to further marginalizations. So with unprecedented level of urbanization, I think Professor Ghosh, Dr. Thang was also mentioning, currently around 50% people are living in areas, and by 2050, it will be around 70% people will be actually living in the cities and the urban areas. So how we actually manage cities, how we achieve the resource efficiency of the cities, that will actually tell the success of our advancement of the circular economy. And it will also the region sustainability in terms of resource security, resource supply security will be to progressively adopt low carbon, resource efficient and circular economy principles in all development sectors. I think as a conclusion, I would like to urge here that as human activities continue to disturb the ecosystems worldwide, we are likely to see more pathogens crossing from wildlife to the humans in the future. Therefore, how we manage our natural resources and ecological assets that will not impact on the type of waste or the amount of waste will be generated, it will also have impact on the emergencies of the health crisis or diseases like this COVID-19. I think last time we were discussing that around 60% of the infectious diseases are zoonotic. That means they spread from animals to humans. So basically, the message is that circular economy is not only about managing the waste. Circular economy is more ingrained towards managing the natural resources and ecological assets. I think when we were discussing the various waste management issues in Vietnam forum and also in India 3R forum in 2018, we discussed a range of this pollution and environmental issues that affects actually the resilience of the communities and the cities or the local people, and 3R and circular economy provides an important basis to build resilience to face this type of emergence of diseases like the COVID-19. So this one, I would like to congratulate once again Professor Ghosh, your team, and all co-organizers to organize this webinar, which is in fact will also contribute towards the next 3R forum, the 10th regional 3R forum, which was actually supposed to be held in Russia, but unfortunately, COVID-19, it will be a webinar like this, which will be comprising of 6 webinars in total, starting from 24th November until 22nd December. Thank you so much.
Thank you very much, Mr. C.R.C. Mohanty. Thank you for your enlightening speech. We have come to know about different aspects of circular economy connected with waste management under this pandemic COVID-19 situation. I request Mr. Ashish Mukherjee next to present his views on the topic, and we'll take up the questions at the end of the sessions because we are all hearing the different aspects and we must be having certain queries in our mind, which I would request the speakers to clear at the end of the session. So, Mr. Mukherjee, please oblige us by your presentation. Thank you.
Honor, please introduce him.
Okay, sir. Good afternoon, everyone. I would like to introduce Mr. Ashish Mukherjee. Mr. Mukherjee is a chartered engineer from the Institute of Engineers, India, and received the MSc degree in physics with a specialization in electronics from Ranchi University. He is currently a principal researcher in R&D Tata Steel in the NDT and Amplifier Sensor Research Group. His research areas include plant scale sensor development for the Tata Steel industry. Since 33 years, he is associated with Tata Steel in different areas of automation and sensor development and implementation. Now, I'd like to invite Sir, and please unmute yourself and share your screen.
Good afternoon, everyone. I am Ashish Mukherjee. Already explained. I am working in Tata Steel last 33 years. So steel, it is a totally depends on the business goes on the circular economy itself. And just in this pandemic, you just can see the landmark of one of the Delhi is Delhi Gajipur area. What a mess we have done in this world, and the waste we are generating, this world, this Indian urban population of 429 million citizens produce a whopping of 62 million tons of garbage every year. So you understand where we are. So next I am going to just show in this outbreak of novel coronavirus not only expose the poor healthcare infrastructure and lack of the preparedness to battle a pandemic, but also loopholes in the waste management processes in the country. According to a report filed by the Central Pollution Control Board (CPCB) in the National Green Tribunal in July, India generates 101 metric tons per day of COVID-19 related biomedical waste. It is a very alarming situation. Now you will find in the roads all the masks are thrown like anything. So just this is a concern. So I will just tell about not only on the COVID situation, everybody knows the things. I will tell how the steel industry goes through this circular economy. Just in this presentation, just you can see the linear business model. Earlier, 50 years ago, our steel company goes through, we've taken the raw materials, design it, produced, manufactured the final product, used it, and on scrap, we generated a lot of scraps. Now, after this, the 1950 onwards, we are now value generating from the disposal waste also. Now the circular economy comes into the pictures, and this circular economy purely depends upon it is a steel is 100% recyclable materials. It's not a single penny can be wasted. So you just see here in the circular economy, basic structure depends upon the steel circular economy depends upon the 4 pillars, that is the reduce, reuse, remanufacture, and again recycle. So based on this, the total phenomena goes on. So, and we have to go to the zero waste. So in the circular economy, the first pillar, the reduce material, that is reducing the weight of the products, because nowadays you will find earlier we were designing the overweight, over designed the product. So slowly we are reducing the weight of the product. Earlier the one cycle what my father was carrying, bicycle, I could not lift up, but my son bicycle I can lift up anyway in a single hand. So this is the you can understand the what is the reduce of a product but maintaining all the parameters. So we have steel makers have over the past 50 years, just I told, that drastically reduced the amount of raw materials, energy recovery systems, actively promoting the development use of high strength and advanced high strength steel materials. You will find nowadays the high strength steel, high strength materials are coming. These are very non-corrosive and very good weldability and material high yield strength is there, like 300 megapascals and all this. So this is a basic concept. If we reduce, then certainly we can gain something. And after that, this is the reuse. So certainly if we are in the steel company, we produce during the manufacturing process, we produce so many scrap generations. So we have to very intellectually, we have to, and optimally, we have to manage the reuse of this scrap, because this scrap generated in the so many mills we have in the steel sector. There are long products like rebars and bars, and in the flat products the steel sheets come out. So all these plants produces a scrap, and this scrap can be reused directly just by melting this. But other than this using of this, there are blast furnace and coke ovens. They produce so many uh, dust kind of things. So that dust kind of things can be reused by again molding them to a another pellet, and after that we can reuse that. Yes, remanufacture. The steel company, I told that we suppose a big machine has failed. So just by the steel part, just by melting that, again we can remanufacture the steel products again. So there are so many other the railways producing the so many railway being obsoleted. Rail tracks, steel rail tracks are obsoleted. So what we'll do with that? We have to reuse that material, and after that we can remanufacture the same thing. Yeah, you just see the recycled things, what I have told. The recycle being carried out in the steel industry since steel was first made. Steel is 100% recyclable and can be recycled over and over again to create a new steel products in a closed material loop. And doing all these nowadays, at Professor Monty just out some of the words that IoT and this digitization. Now we Tata Steel involving 100% digitization of this process to make these things very efficiently doing the things. And you just see the left part is scrap generated. We directly put it in the hot metal bucket. On we pour the directly charge this hot metal to the in the steel LD vessels for making the steels. Now you see the we have this service life wise. We have I am going to show that we have so many steel products which are domestic applications. Some are automotive, some are metal products for home use, some are electrical equipments and building infrastructures. So these color wise you can see this long service life and the medium service life and the short service life. We have the durability of the materials. Yes, it is another view how we arrange the things, whole things for weight reduction benefits to get that. How nowadays you can think of older days the ambassador car was a very heavy. Now you can see the still the same car but with the better advantages. We are sophistication. We are getting a light automotive vehicles. Similarly, in the construction part also. Now in the construction part, we are not using very much bricks and cements. Some parts we can make the light structural steels also. By that we can make the good constructions for which are in the very vibration prone area zone and all this. And same also packaging. Now in the packaging also now from the our cold drinks packaging packet, you can understand how much thin packets all these cold drinks package, they are thin. So these are the only due to the reduction of the waste it was possible. Now you see, I will tell some of the things on the how construction wise, year wise, the energy has been reduced. Global steel production has increased almost in fivefold since 1960. But you see, the energy consumption has been reduced 60% per ton of steel in the same period. Production has gone steep, but slowly by time we have reduced. Just by using the sophisticated tools, the mathematical modeling for the process as well as product sides. So we have achieved this. So we have now also still our company is aiming to long way to go to again. So using the proper in the coke ovens area, we use the now at present we use coking coal, but now we are going for the non-coking coal also can be used for the steel making. So this is the things. Now I'll show steel making byproducts, steel and waste. The percentage wise, we produce 32.9 is the byproduct in steel making process. 64.4% is the steel, pure steel produced for this production for the final sale, and 2.7% is the waste, which is not as a waste, but also again we use for the sometimes landfill, sometimes like our the blast furnace, the slag granulation production, it goes as some we use for the cement manufacturing, we give a supply to the cement manufacturers, and some again used for the landfilling process. In the slag and dust, the cement, fertilizers, roadstone, asphalt, these are the user. The process gas and the zinc iron we again use is for the paint and all this. And waste gas we use for the electricity and other heating for the boilers. And for the paint generations we and for fertilizers we produce so many other byproduct from the coke ovens area. Now this is the attributes and benefits by utilizing the circular economy in the steel process. To just understand where is the steel attributes for the infinite recycling without loss of process, the permanent materials, and some of the materials we again collect from the by magnetic pickup and all this. And the benefits of steel recycling, the raw materials conservations, 1 ton of steel recycled saves an average of 1400 kg of iron ore, 740 kg of coal, and 120 kg of limestone. So you can understand how we can reduce the burden on the earth, our mother earth. So these are the things. And 70% energy savings. Recycling a single steel can save one laundry load. To just understand, 1 hour TV and 24 hours of 10-watt LED bulb. So for doing this, not only by doing this circular economy applications, we are evolving more jobs for the next generations coming. So this is just I am showing. You can understand this in the under the attributes and the benefit, how the production process goes on the raw materials, coal and coke, sinter, pellets, and then it is being recharged in the blast furnaces, and then by the reduction, some part goes to these hot gas generated, that I will explain in the last presentation. I will show what is this. And in the steel making area, there is a open heart furnace earlier. Now most of the Indian now it is not utilizing open heart furnaces. Now it is totally BOF, basic oxygen furnace, that is totally with the oxygens. So no, we don't use any oil for making the steels now. We totally on the oxygen process, and some are the electric arc furnace and so on. So just there is a picture. You just can you there is a how can I run this? Sorry, there is a good movie. Can it be run? Hello. Uh, yes. Yeah. So you have seen this how the total cycle is being maintained. So I'm just showing this one of the there are so many datas are there, but only the important data. Just you can imagine this 2014 and 15 and 2019, just 5 years paradigm shift where we have achieved the capacity, production, and the solid waste generations. So now I will typically show the waste management, some of the glimpses of the waste management. It is the waste hierarchy, the prevention. If you cannot prevent, then prepare for reuse, recycle, and recover and disposal. Now I will show a typical application for the waste heat utilization. What we just by just dump water spraying. Now what we are doing, this hot coke is being taken care by the bucket, goes to a chamber where from the blower, the inert gas like, yeah.
You have only 1 minute in your hands, sir.
Okay. So just I am showing this is the things. So we are generating around by this waste heat utilization, we are 14 megawatt electricity we are generating. Okay, thank you.
Good.
Okay, thank you.
So thank you very much.
Thank you, Ashish.
Thank you very much,
Okay.
Mr. Mukherjee, for your
Thank you,
very
Mr. Mukherjee. Very,
interesting.
very enlightening session it was.
Yeah.
particularly in context with Indian scenario, where we have to go for high-rise constructions, use of steel is
Yeah,
absolutely essential. And if we can achieve steps, if we can take meaningful steps, effective steps to economize steel consumption and consume less energy in the way of producing steel, that will
yeah,
have certainly.
yeah. Now we are also doing some on the as a product Tata Steel Nest In. It is a prefabricated steel materials for the housing area. We are doing so many work that you just within 2 days a building can be constructed on the cement floor.
Oh, I see. Is it?
Yeah, yeah. For a single
Sir,
room and
actually,
all this. Recently, in the pandemic situation, we have done some of the nest-in structures for the rural areas for quarantine centers. These are the things.
I think, sir, you have plans to set up cement plants adjacent to your steel plants, because as Professor Sadhan Ghosh was speaking about, that the unused
Yeah,
product of plant should be used as inputs to the next plant. So you must be having cement plants adjacent to your steel plants, no, sir?
no, at present not. We are now just giving to the outsourcing to the third party. They are making it. So we are just involved in the quality to look
Steel
after the
production part.
quality part.
Okay. Okay, Mr. Mukherjee, it was excellent hearing from you. Now I'd request Professor Hung Trung Hai to deliver his presentation. Thank
Okay,
you.
thank
Thank
you,
you, Mr.
Pat.
Mukherjee.
Okay, thank. It is a great pleasure for me that I.
Thank you, Mr. Mukherjee. Thank you.
Okay,
Thank you, Ashish da. Thank you. Thank you, Ashish
thank
da.
you,
Let us
brother.
move Hung Trung Hai now then.
Very nice presentation.
So, good afternoon, everyone. Thank you
Good
very much.
afternoon, sir.
Good afternoon. Good
Good
afternoon.
afternoon.
Excuse me.
Once again, good afternoon, everyone. It's quite very nice for me to be invited to deliver a speech in this online conference. So, my topic is research and circular economy nexus. Before I talk, I would like to introduce a little bit myself. Truly speaking, I'm a professor in the environmental engineering, but now I'm a director of the research management office. I'm responsible for whole university research activity as well as technology transfer activity. So therefore, my talk is more general, related to the research and in context of circular economy. So, my talk consists of circular economy introduction. How is the circular economy in our country, in Vietnam? The next one is research and development in circular economy context, and how the circular economy research and development in our university. And last but not least is some conclusion remarks. So, as Professor Ghosh, Mr. Mohanty, and Dr. Thang already mentioned about the definition as well as the approach of on circular economy, so I will skip that slide. So, as you see, the truly speaking, some of our country now is now in a linear economy, a little bit higher than linear economy, and we need to shift to circular economy in order to save our natural resources as well as protect our environment. So I will, and in context of the circular economy, we have some common points such as mainly to waste minimization. We can call 3R, the lead to the co-benefit of environment and economy. The second one is diversification of output and input, and renewable energy toward a biological closed system systematic thinking. So we can change from 3R to 6R in CE. Rethinking how we can use our products and how we can use our natural resources, and we redesign our product. How we can redesign our product for the when the community can accept that our new design, and we use as much as possible repair, recycle, and recover. So, and I can call that is 6R, not 3R. So, upcycling and circular economy is more than sustainable consumption and production, exploitation and reuse of the natural resources, improving energy efficiency. Therefore, we did not have systematic approach for circular economy model building. We did not have some actual circular economy models, but we have limit in small scale and effective, such as the garden fishery husbandry model and sugarcane paper fermentation, and I will show a bit later. So I think that in the book published in the beginning of this year about the global circular economy perspective, Professor Ghosh is editor, showed some legislation and policy in our country related to circular economy. So therefore, I did not mention more than that. So I would like to show one example. Quite a very long time ago, we did not, at that time, we did not have terminology circular economy, such as from the Babim company is the sugarcane production. From sugarcane production, we can get the alcohol, we can get the hot, we can get the ash for fertilizer. As of course, beside the main products is sugar, we can get palm and paper. So it's one example of the sugarcane production. Another one is some example: fresh fish to eat. Second one is vegetable for family, meat and eggs for family, food scrap for the animals, waste vegetable for your animals, water for garden, water for your animals, and fertilizer for your garden, animal, manure for the ponds. Is some kind of how to say, in the farmer mainly in the south of Vietnam. So from my point of view, the challenge of circular economy in our country is we did not have any legislation document related to the circular economy as well as a guideline. We lack of support legislation. We do not have potential market. This means that we should change. We should have market for recyclable material, renewable energy promotion, as well as the market measure to promote the recyclable material, recyclable products, something like that one. And the next one is ability to utilize waste in Vietnam is still small. And the production technology as well as the machinery are mostly quite average and very old. The cooperation of all stakeholders is still based on the economic benefit. We need to change our thinking. We need to change our attitude, as well as we need to have some legislation, and we need to have some support legislation in order to implement CE, as well as some component of CE in practice in order to protect our environment as well as to promote our economy. So CE just introduced in our country quite for a very short time, some research and development operation are just mentioned related to the reuse and recycle of waste, cleaner production, improving energy efficiency, such as some research and development project related to the CE, such as the cycle of electronic waste. I pay quite a lot of attention on the recycling of electronic waste. Another one is recycling of biomass. Professor To Kim Anh from our university is also the expert in this thing. Another one is recycling of plastic, reuse of fly ash and sludge, recycling of construction waste, recycling of food waste and sludge from wastewater treatment plant, etc. We aim to solve a single object, not all the component of circular economy. So, and our model is in a phase or small scale. So we have some example, some research related to the circular economy, such as the green hub for plastic waste. In Ho Chi Minh City, there is new regulation on domestic waste segregation, and we have the Monterey is also issue some regulation related to refuse plastic water bottle, and in the state of production to use of modern equipment for producing plastic products, and in the design stage we have some kind of alternative to single-use plastic to change to grass, bamboo, and rice. So I would like to show some the research development some technology developed in our country from the municipal solid waste. We can sorting, we get the metal waste, and we get the biodegradable waste in order to carry out compost, to get composting. And polymer waste, we can get the pellet plastic product or RDF. And the non-biodegradable, we can go to for the construction products. Another one is the cassava production. Cassava production, we can get the cassava starch, and we can get the product for agriculture, mushroom fertilizer, bioethanol, animal feed, cellulose materials, and biogas. In the term of the e-waste recycling carried out in our university, we already set up the scheme for the electronic and electric discard appliance for the recycling and reuse. Another one is the some kind of research and development in our country is the in Tân Phú Plastic in Ho Chi Minh City. We change the technology, we get out the technology is change the reduce energy in the context we can get the energy consumption is reduced, and we can saving a lot of energy as well as the budget and the emission, the CO2 emission. So how is circular economy in our university? How we carry out research project as well as R&D project related to the circular economy. So as you know, we have our university is the biggest technical university in our country, and you have seen some the academic staff, students, school, and faculty. I will not go in detail. And we have some ranking is I will skip that slide. We have some memorandum of understanding. We have the incoming, ongoing, the student, and international as well as the abroad. So as you know, you may know that our university is the biggest technical university in our country. So we recognize quite a very important role of leading technical university in the country. And we have defined, we have set our 4 scientific direction, such as data technology and smart system, advanced materials, sustainable energy, environment, health science and technology. And as you see, for our priority direction is mainly related to the circular economy. So I would like to show some figure. So cooperation tasks under the protocol from 2012 to 2014 is about $3 billion US. The another project is National Key and Technology Program. We are see context account 2 to 5. And the Ministerial Research Project, we have 20 research projects related to the circular economy in the 130 projects. And many cooperation projects with enterprise related to the circular economy context. So some typical research and development project in our university, I will skip that. I think you quite are not interested in very detail. So you will, the organizer will, if you have would like to have that kind of slide, you can ask the organizer to send my PPT to you later, and you can look later. So I will show another example. In our university, we carry out the technology transfer in the term of clean circular economy, but it's not 100% is circular economy. It's just only like sustainable consumption and production. We can save about $100,000 US annually, and we reduce water consumption about 30%, electricity consumption 20%. And ice consumption about 10%, and the fuel about 12%, and environmental benefit is about wastewater reduction about 30%. Another example is the resource efficiency and cleaner production application. In another company is reuse cassava residue for the compost production. Investment is quite very low. It's about $75,000 US, but we can get the benefit $50,000 US annually. Environmental benefit is reduce solid waste about more than 1,600 tons annually. They avoid odor, dust, and pollution from the dumping site. Another project is we call the symbolic map for the industrial zone opportunity selected for feasibility study. As you see, is the industrial zone. We have the own company. We have national electricity. We have the SAM, water heat boiler, glass company, and we can carry out some kind of how to say, ecological industrial zone. It's maybe like that. So I come to some conclusion that circular economy is just a new concept in Vietnam. But I don't know how in India or in other countries in our region, like in Indonesia, in Thailand, or in the Philippines. But in our country, it's just a new concept. This now legislation as well as official guide for integrated approach to build and develop a circular economy model that can satisfy basic principles of circular economy. Many single operations have been conducted that related to the circular economy context in our country. We face up many obstacles and challenges for construction of circular economy in our countries. The benefit of research and development in circular economy context is quite very clear. And I would like to add a little bit some information related to the research project related to the circular economy. As you know, nowadays the research project in the field of chemical technology, biological technology, or food technology, or the another thing, the
Uh,
the,
excuse
the
me, Professor. Hi, your time is almost over. Kindly
yes, yes,
conclude soon.
only 30 seconds just. And one component of circular economy is also in the research content of the title project. So it means that we need to prepare legislation framework for CE integrated to improve the management system, to share information, to cooperate of stakeholders, to create and promote CE related market. So thank you very much for your attention. I wish all of you quite a very good health and our conference quite a very success. Thank you very much.
Thank you, Professor Hai. Thank you for your enlightening speech, mainly outlining the awareness aspect and corresponding legislations. Now I'd request Mr. Umashankar Chowdhury to deliver his presentation.
I take this opportunity to introduce Mr. Umashankar Chowdhury, who is the technical head J&K Cement, Muddapur, India, is presently spearheading as technical head in JK Cement, Works, Muddapur, India. A technically adept and methodical professional with 22 years of cement industry experience in production, quality control, environment, and AFR, procurement, utilization, along with plant operation and process optimization. During long tenure as a cement professional, he has been working with lead players of Indian cement industry as well as overseas assignments. He has been served in different organizations vis-a-vis Digvijay Cement, Ultratech Cement, Thyssen Krupp India, and JP Cement organization in past 22 years. He has also given his utmost contribution and services towards the industry through seminars, training program, and presenting articles in several national and international conferences, magazines, etc. Mr. Chaudhary, kindly unmute and share your screen. You have 14 minutes to present your deliberations. Thank you.
Good afternoon. Thank you. Thanks giving the chance. I am here to present regarding the co-processing of waste, a true business model of circular economy in Muddapur plant. I belong to, as already you have explained regarding cement plant, and I am representing here for JK Muddapur. So JK Cement is a part of industrial conglomerate that is promoted by our late Singhania ji, and this group entered in the 1975. We having 16 million ton per annum of cement capacity, that is white cement capacity of 1.2 MTPA. In Muddapur plant, that is 2.2 million ton per clinkerization, as well as 3.5 for finished cement grinding. And JK Cement Muddapur is certified with various ISO system, Green Co Gold rating, and our group is great place to work, certified company. This is the AFR availability concept that is I have put here, that the butterfly. So this is the availability. So availability AFR is abundantly available. Just take initiative and get the AFR to use in the industry. That this is a national this is a national mission of the Swachh Bharat, and already this has been mentioned as Swachh Bharat course. Our PM Narendra Modi has taken a great initiative for this as a social responsibility, as well as our Vice President has also taken that this reduce, recycle, and reuse. So this has become a national initiative, national mission. We are all the part, all Indian are doing in this mission and taking a very good initiative and become a part of member to become a clean and green India. So this is our today agenda, that is AFR material, type of waste, processing and co-processing. Today's agenda, that is the Muddapur AFR usage and roadmap, as well as impact of AFR on clinker quality, as well as a challenge. We will discuss about the challenge and static initiative. This is AFR Indian cement industry. As you know, cement production in India is about 545 million ton per annum, and India is the second largest cement producer after China. And for that, estimated coal requires 40 million ton per annum. You know there is natural resource, so we cannot increase the natural resource. We have all to think about the conservation of natural resource. For that, India has the potential to use the entire hazardous, non-hazardous waste generated if suitable for co-processing that can be used in the cement industry. And you know, as is the in all industry, there is the energy cost is the almost this is threshold limit. So that is 50 to 70% compromising of both thermal and electrical energy. So we are focusing this. If in the graph you will see that 91% is cost coming from thermal as well as electrical is 9%. So our target is conserve this 91 to the main fuel, that is the petcoke, coal, everything. So this conservation of energy and use of cheaper renewable alternatives has assumed greater importance for improving productivity as well as the reducing thermal energy consumption. As there is a just data that is 95 is the million ton per year generated. Out of that only you can say that it reaches 16. And this data for the 2030, 245 million ton maybe generation per year in India. But again, it will be treated only that is the we have to think if generation is almost how this can be treated and that can be used as a co-processing in Indian cement industry. So this, as you know, that is in the cement industry, the best industry for the use of all type of alternative hazardous, non-hazardous. This is the hierarchy of the waste management, and you can say this co-processing is the best because incineration, for incineration again you are required to fuel, and this has become a problem. In cement plant, this is a co-processing is the best method. We have to co-process, and there is no waste generation, no extra fuel is required. The cement industry having the temperature as in 1450-degree temperature that can be all material can be co-processed in a safe manner. This is the average database analysis. That is in India there is only 4% generation, and you can say this number one is the European country, that is the Germany, Austria, that is 70 to 80% utilization. So we have to think about and learn about the European country, how this is going, and this can be continued in the cement industry. Yes, in Indian cement industry also fast moving. Last 3 years from 1 to 4 to 5% at percentage PSR. So we are moving in the right direction. Now this can be the economical growth, sustainable development. This will be environmental performance as well as the social progress. So this could be the goal and challenge. This is the global goals as well as individual goal. So this is the saving of natural resource for the global goal, reduction of CO2 emission, as well as individual. Some third party has to introduce that can be earning well by the disposable fee, negative fuel cost. Some challenges is also there because the identification of right kind of fuel, right kind of alternative fuel, and the preparation of waste to AFR, as well as the required to right type of equipment for the co-processing. Material which can be used as AFR must have calorific value, that's suitable physical and chemical property, and this cannot be reused, recycled. It is like I can say that the Indian cement industry or any cement industry can use all type of raw material as alternative raw material as an alternative fuel. So in cement industry, that is the crushing, grinding, burning, and finished grinding of cement. So you can say by this cement plant layout, we can use all type of alternative raw material as well as alternative fuel in Indian cement industry by the bifurcation we have provided. So we can in kiln for co-processing in 3 layers, that is in calciner, kiln, and inlet, we can co-process. This some type of waste that waste is available in the all over the world, that is hazardous, non-hazardous, municipal, commercial, and agro. And this is following is the characteristic, and this type of waste is coming in this category. So that is the first thing is pre-processing is required before we got any material with screening, then size reduction, homogenization and mixing, then it can go to the cement plant. This is a circular economy, like that is typical pre-processing model, that is MSW has collected by municipal corporation, it can go to rural development, ULB, and by then this can be cement plant. This is around within the radius of 2 kilometers. All plant can take immediately, and this expense to be borne by the municipal corporation. And the grade 1, grade 2 material can be directly utilized in the cement industry, and rest materials can, if there is no CV, it can be going for the landfilling. So this is the co-processing, use of waste along with our existing process in environmental friendly. When that is talking about the co-processing, that is peace of mind. So this we have to concern about the quality of clinker, cement, and as well as the monetary benefit in the form of co-processing tea, which available in the market. When we are talking about co-processing, in that conditions, some condition is there for co-processing. Should be the calciner, we have to feed the CV more than 4,000. Moisture should be as lesser. Chloride content should be lesser. Availability of right kind of feeding equipment, and as well as we have to decide about the raw mix and fuel mix. So this can be the better quality of clinker, and after that better quality of finished cement. So if more than 10%, 50% substitution is there, then required of the chloride sulfur bypass to and continuity of the cement plant. This is the co-processing, that material feed to calciner for co-processing, monitoring of clinker parameter and desired quality, so that can be not deviate to the clinker quality, because we are producing our product is the clinker. So we have to main focus during usage of all time. We have not to deviate about the clinker quality. And I can show you the cement plant, there is no waste, because cement plant is having having the property to inhale all types of waste available in the all over the country and all over the world. I can say there is a Hindu god, that is a Shivji. Shivji can inhale everything like cement industry can inhale all type of alternative fuel as well as raw material, and it can be co-processed, it can be used in the cement processing without any affecting of quality. So this is the availability of that is thermal power plant and oil industry. I have seen the presentation regarding the steel industry and other industry having several type of waste. So all waste can be utilized, can be accommodated in the cement plant. So like CBG can inhale all the thing, the cement plant can inhale all the waste and without the sacrificing the quality. So this is the waste generator, and we can utilize the waste in the cement industry. I can say this is the Indian state. This is some tentative data about the alternative fuel availability, that is generated as well as treated. So you can see that is only 25% of generated waste is treated. So we have to focus for the treatment plant, that is the waste can be used in the cement industry. And I can say you that Indian cement emitted only 137 million ton of CO2, which account of only 7% of total CO2 emission in the environment. This is MSW generation by the country. You can see this is the Netherlands, that is European country. India at present around the 40% generation, as well as the China, United States around more than 200 to 40 million ton per year. So in Indian cement, we have to more focus about the collection as well as the treatment. This is the circular economy, like that. This is collected through the household, and this is the best, that is co-processing. If you go the right type of material can go the cement kiln, and if there is no CV, this can go for the landfilling, the inert filling, recycling, compost. So every type of it. But best is the if the right can go for co-processing at the cement kiln. Now this is the if there is a change in mindset. Go 20 years back. There is the that is a scrap yard. This is available in all the plant in the corner. If you find there is a scrap yard, so now this mindset has been changed, and nomenclature has been changed from a scrap yard to waste management and control area. So you can see this is a systematic approach to collect, segregate, and it can be reused as a waste. That is the waste management. So for achieve that is the 25% the forecasting for the FRUM India. At present, I already told around the 4% TS of thermal substitution, and for the up to within 5 years we have to achieve 25% TSR. For that, cement industry, Indian cement requires 7 million ton of oil equivalent energy from the alternative fuel. This is some types of fuel, that is the municipal waste, biomass, tire waste, hazardous waste, and this is the availability. As 80% was sent to the dump yard. So we have to keen focus about this segregation as well as the all type of waste is available. More focus to be how can be corrected and go to the cement industry. That is a several type of waste, that is spent fertilizer, hazardous, tire waste, biomass, MSW. You can say 57%. This is MSW. This is major part. This is fulfilled by the cement plant, and this doing a co-process of the MSW. So we have to giving more focus for the MSW. RDF and rest are the hazardous waste also. And what will be the benefit if we can achieve the 25% TSR within 2025, within a 5 year? So coal consumption can be reduced by 25%. Land filling area requirement in the country will be reduced by 20%. You know, at present, what is the generation if the consumption will be not properly done? So in the capital, our Indian capital, Delhi size, what is the Delhi area? This size of area is required to store this AFR material as MSW. So we have to think about the consumption, so that is the reduction of the area by the using, so it is not required for the land filling. GHG emission from fuel, it will reduce by 25%, as well as reduce import and increase economic activity of the country. And this is the data that is the coal consumption as well as the carbon emission and land filling area. Now coming to the our plant, that is I belong to JK Cement Muddapur. What is the we have started 4 years before that, only 1%. We have started with a small system we have installed and we have started our journey. So see, and after that, when we have seen yes, we can use in our plant without affecting our quality, immediately after 1 year we have installed the automatic system that is 20 ton per hour feeding capacity. Now we have installed a shredder. So all MSW RDF is coming and he has to go to the pre-processing and it can utilize, it can go directly to the kiln. There is all safety arrangement, safety precautions we have taken during the usage of this. It can go for the preheater, pre-calciner for the co-processing. After that, we have installed the liquid feeding system because several type of liquid waste is available in the all industry of the hazardous. So we have to utilize that is the earlier it was going to for incineration, that is TSDF side. This is again the problem creating for the ash generation as well. It is required to fuel to burn, but in cement plant this can be utilized all types of waste or conditioning as already regarding the chloride content as well as sulfur. This is our journey 2015, only 0.73% our TSR. Now last year we have achieved 10.8% TSR, that is we have replaced by GCV our third main fuel, that is the coal and petcoke. And we have consumed last year around 63,000 this AFR alternative fuel in our kiln, our cement kiln. And in this year journey is continue. So this is the monthly, you can say even 16.22% we have achieved TSR in the February month. This is the bifurcation of solid waste as well as the liquid waste. And by this,
excuse me, sir.
Yes. Within 1 minute,
your time is all.
Yes, okay.
Yeah, thank you.
This is coal saved and this is the CO2 reduction. So this is the benefit. Already I have explained regarding 1400 degree temperature. Some challenges is also here. So we have to focus on the size as well as moisture percent and CV. This is the AFR quantity where we can get the all industry, you can say footwear, toys, and that is the pharmaceutical farm. You can get the AFR. This is the, you can say property of this GCV, ash and moisture percent. And this is our roadmap. We have to achieve 50% for 22-23, and we have to consume all types of waste. This is the quality. There, you can say there is no quality variation. Even usage of that much quantity, there is no adverse effect in the quality. Is the blended cement in fly ash and slag addition also they remain same or even increase. So this is the key challenges when we are faced for the using. And this is the required preheater, oxidized atmosphere, high chloride, refractory consumption is the challenging when we are using. So this is some glimpses in our plant for the solid AFR. This we are proper storing, proper taking care of material. This is our liquid AFR feeding system glimpses. And this is we are doing of agro waste as well as the colony waste. All types of waste we can utilize, we are doing. As well as we are more focusing on the safety issue. We are daily giving the TBT toolbox talk to our workmen who is engaged in this area. So there is not to be safety. So our engineer is always giving the, before the starting job, is giving the guideline daily basis. So never.
Excuse me, Mr. Shankar, kindly conclude.
Yes, this is thanks. Concluded. Thank you thanks from my side.
Thanks, Mr. Umar Shankar. We have heard about the cement industry and the steps we have taken that you are adopting. Very interesting. And I would like to request Dr. Huven Huang Nam to deliver his presentation.
Okay, thank you. Bye.
Dr. Wong, please.
Before Dr. Nam starts his deliberation, I would like to remind all the participants to kindly put their questions in the chat box and to indicate for which presenter it is meant for. I request all participants to kindly put their questions in the chat box and kindly indicate for which presenter it is meant. I now request Ms. Jaita Banerjee, Research Scholar, Calcutta University, to kindly introduce Dr. Nguyen Hoang Nam.
Hello, good afternoon, sir. Good afternoon, everyone. Myself, Joyita Banerjee, research scholar, and I'm now going to introduce Dr. Nguyen Hoang Nam. Obtained his bachelor degree in economics from National Economics University, Vietnam, in 2007, and PhD in economics from La Trobe University, Australia, in 2014. He was a lecturer and researcher at Faculty of Urban and Environment, National Economics University, Hanoi, Vietnam, from 2007 to 2017. Currently, he is a researcher, policy advisor, and lecturer at Institute of Strategy and Policy on Natural Resources and Environmental, ISPONRE, Vietnam. Professor Nguyen Hoang Nam is an author and co-author of several books, several research projects, and numerous research papers published on domestic and international journals, and also conference proceedings. His research interest is in the area of natural resources, environmental economics expertise, ecosystem valuation expertise, energy economics, payment for ecosystem services, and cost benefit analysis expertise, real organ analysis expertise, etc. Now, I request Dr. Nam to kindly unmute and share your screen, sir. Now, the next 14 minutes is yours. Dr. Nam,
The
please
next
share
two
your screen, sir.
speakers in this session are requested to kindly maintain their time at 10 minutes because we are running late.
Yeah,
Thank you.
Thank you, Ms. Jayata Maji, for the wonderful introduction. And yeah, let me share my screen first. Can you see my screen now?
Yeah, go ahead.
Thank you. Right, so the name of my talk is Circular Economy in the Post-Pandemic Vietnam. I'm very proud to present this on behalf of my colleagues from the Institute of Strategy and Policy on Natural Resources and Environment. And some figures and findings here are the results of my previous collaborative research with some colleagues sponsored by UNDP and some university as well. So I'm very thankful for that. My talk has four parts: introduction, some related policies, and practice, the pandemic, and challenges, and conclusion. I just go quick. Okay, so a little bit of introduction. We all know about linear economy that causes resource depletion and waste increase. And we now need 1.7 Earth to meet the world resource that we need today. And in terms of waste, we produce too much waste. The waste is increasing, and by 2050, the total volume of only plastic waste discharged into the sea would be more than the total volume of fishes. In Vietnam, we also facing a serious problem. Solid waste increased by 10% per year, and that's the number in 2017. And in 2018, it was predicted by the World Bank that we will get around 15.9 million tons of municipal solid waste in 2030, and 21.96 million tons in 2050. Nevertheless, just last year, MONRE, the Ministry of Natural Resources and Environment, just released a statistic telling that we already reached 25.5 million tons in 2019. So we don't know how much waste we will have in 2030, but that would be definitely more than what the World Bank predicted. And Vietnam is now ranked the 4th in the world in terms of plastic waste discharged into the sea. And with the waste increase, we are facing serious problem of air pollution that cost Vietnam about 5.18% of the country's GDP in 2013, and water pollution only cost 3.5% of the country's GDP in 2035. That is predicted by the World Bank. And we all know that with all the disadvantage of linear economy, the global is moving towards circular economy. And I'm so grateful that I have heard a lot of experiences in India, a lot of lessons that we can learn. And so, yeah, I also want to share some information about Vietnam. But firstly, let me tell the economic benefits of circular economy. Globally, it is predicted that we get about 4.5 thousand billion dollars. Europe only can get about 600 billion euro per year up to 2013. And circular economy would have created about 500,000 jobs in 10 years and reduce greenhouse gas emissions significantly. In Australia, where I did my PhD, it was predicted that about 26 billion Australian of benefit will be made from circular economy. And so Vietnam aware of the benefits, and also we started quite early thinking about circular economy and the aspect of circular economy. We started in 1999 with the Directive 36. Let me explain the graph first. The upper part, the red part, is the Communist Party's directive and resolutions, which are mainly the orientation for the countries. The country law and decisions are made by the government, are illustrated down here in black color, law and strategy. And in Vietnam, usually law and strategy of the government would follow the directive and resolution issued by the Communist Party before, right? And as you can see, the country started thinking about a circular economy quite a long time ago, but just some aspect of it, like support the clean technology, apply clean low waste technology, and consume less raw material, and 3R in 2004. But from 1999 to 20 years later, we have more and more policies established, and recently we have more than I can list down here. So you can see that the movement towards circular economy in terms of policy framework is definitely happening in Vietnam. And because of the movement, the active movement, we also have some practice, some good practice, but there's still some disadvantage, some kind of lacking, some challenge that we have to come over in terms of policies. Firstly, the term circular economy is not officially used yet in any policy in Vietnam, and therefore no comprehensive policy for circular economy established. Just some, as I mentioned, part of it or aspect of it, like 3R, renewable energy or so. And we also found that limited attention on the upper part, the design phase of circular economy. As Dr. Ghosh in his presentation also mentioned that in India, you are also trying to look more on the upper part, and Vietnam also trying to do so. So it's a very promising chance that we can collaborate in the future and learn from each other. And we also found that the extended producer responsibility, the EPR, not specified. It was mentioned in some legislation, nevertheless, it's not so specified that it can be practical. And the last finding that we found here, standards for secondary materials are missing. This standard for secondary materials are particularly important for the fifth phase of circular economy. As you can see on the 5 phases circle on the left, starts with design, then production, consumption, waste management, and waste to resource. And in order to do waste to resource well, we need the standards for secondary materials, and we are in need of learning international experience on that. And I just heard that India is well far in front of us in terms of waste to energy. We really want to learn from you. Right, so let me turn to some more detail of the typical practice by grouping the practice in some groups, but not necessarily they are staying in one group, because some would like can be put in some groups even, not just one group. But let's start with agriculture. VAC, RAC is other models that Dr. Hai already mentioned, so I don't have to describe about it again. It's the garden fishery and model long time ago, and it's very effective in the countryside in Vietnam. Mộc châu cow farming with the biogas also mentioned partly. And we also have some handmade products from rice straws, and recently we have some models that utilize secondary products from seafood processing, including shrimp shell and shrimp head, to produce chitosan and SSE, which are the important substance for cosmetic, and it can bring great benefits of about $4 to $5 billion per year for Vietnam. And in industry, we also have some existing model of cleaner production, which started since the 1990s. We also have eco-industry parks that is similar to some certain extent to the excellent cement production in India that I just heard in the previous presentation. And thanks to the very beautiful and very informative presentation there. We really want to get your slide and learn from it. But in our country, we also have some eco-industry parks that help us save $6.5 million per year only in 3 eco-industrial parks. Plastic, paper, iron, and other metal recycling also a part of our concern. And I just have to name one company here, Cycling Plastic, because it's not just we have many domestic companies that are doing plastic, paper recycling, but Cycling Plastic is the first, could be, as to my understanding, foreign startup in Vietnam that is doing this work. So very much promising, and very happy to know that we got some foreign investors getting into the field. From recycled plastic to road, we also have an investment from Dow Chemical and Deep Sea. Deep Sea is the industrial area, and we just have the first plastic road last year. In service, we also have some examples of circular economy, making full use of food left over for farming. Is common in the past, and also very common now in the countryside. Deposit bottle, also, as you can see from the photo, sorting, collecting, and recycling waste. And one name that I can tell here is Green Hub, government organization doing great work in many provinces on sorting and collecting and recycling waste in Vietnam.
Sorry to disturb you, sir. Sorry to disturb you. Please wrap up within 1 minute, sir.
Sure. And we also have Zero Waste to Nature by VCCI, and we have the Pro Vietnam doing great work. So very much promising. One thing I want to emphasize here is we in Vietnam are trying to look on the upstream area of circular economy to really do the circular economy effectively. Just some update on the pandemic. We now have 1,066 confirmed cases, but all domestic flights resume and some works are coming back to normal. Nevertheless, the interruption of economic activities can affect the recycling business, and so reduce the recycle rate. That's what we really worry. And from a research that I discussed with a scientist from Harvard Kennedy University, we also found a problem here. Immediate priority in surviving from the recession may delay important policy change, and also the same issue with business. So quite hard for the startup to do more work in circular economy. And informal sectors are getting quite vulnerable. So I just want to wrap up my ideas by mentioning one sentence by UNEP and OECD. Circular economy is the best way to decouple natural resource use and environmental impact from economic growth. And by doing so, we can really comfortably get to sustainable development. Thank you so much for listening, and my great pleasure to attend this seminar. Thank you.
Thank you very much, Dr. Wang. Now I'd request Mr. G.V. Ramakrishna to present his topic.
No, he's not G.V. Ramakrishna. It has been changed.
Oh,
please introduce. Go by the.
Oh, sorry. The speaker has been changed. I did not know. Okay.
Yeah.
I will take this opportunity to introduce our next speaker, Mr. Gaurav Patel. He is our next. He's our next speaker of today's technical session, and most probably he is the last speaker. Mr. Gaurav Patel is currently associated with Dalmia Cement as Assistant General Manager in Manufacturing Core Team in Noida. He was Assistant General Manager in Lafarge Holcim in India from October 2005 to January 2020. He obtained his bachelor degree in chemical engineering from Pune University. He is experienced in the field of cement process and optimization, responsible for co-processing of green fuel along with suggestion recommendations for kiln system modification required for increasing TSR and capability development of plant process engineer and CROs in co-processing and emission. He is a certified energy auditor by Bureau of Energy Efficiency. The next 10 minutes is for you, sir. Sir, please
Okay.
unmute yourself and share your screen. Please maintain the
Thank
time,
you.
sir. Please 10 minutes.
Sure, I will. Yeah, I will play 2020 for this now, because mostly hope I'm audible to all. Yeah. So starting with it, that this presentation was supposed to be given by Mr. G.V. Ramakrishna, but due to some emergency, he is not available, and I will be going ahead. Circular economy, we had seen many speakers have already spoken. Most of it, like turning waste is a resource, one of the key to this circular economy. But one thing I would like to mention is the combination of energy recovery and material, which is called as co-processing. So in the green, whatever material is prepared, we say that we don't co-process any waste in our cement industry. Like the earlier presenter, Mr. Umashankar, has given, that there are pre-treatments to be given for the waste. So once this pre-treatment is given, pre-processing is done, we refer to them as a green fuel for us, or the green materials which we will be able to consume or co-process in our kiln system. The only difference between the waste and the green fuel is the quality assurance. Waste comes in many shapes and sizes, and the fluctuation, heterogeneous in quality. But for green fuel, what we make it is a consistent quality in size, in the quality parameters of moisture, the chloride and everything. So this is the main difference between waste and GF, to easily and consistently doing the co-processing, increasing the TSR. This we had already seen that how the co-processing has given an upper hand in the recent years only, where it was below the incineration and now it is above the incineration process, which is giving us the upper hand for the waste industries to send their waste, and which can be co-processed in our cement industries. Further, the importance of use of GF is that it will reduce the cost for the cement manufacturing. It also provides a waste management service to the society and generate a business. The main important part which I would like to process is that the MNC companies which are investing in the India or the other countries from outside, they will have the assurance of their waste disposal. What happens if they give it to the landfills? Then the landfill mafias will dig out the material from the landfills, and they will sell it in their gray markets. So this way it will hamper their brand image. So if we give them the assurance that your waste, which are expired products or the undesired products out of their quality limits, will be co-processed in our industry, in our cement industry, without any selling in the gray markets. One example was there when there was an issue with the Maggie. So in the Lafarge Holcim, we had done it in 3 months. We had eaten away entire Maggie, which was rejected because of the issues, without any reselling it in the cement in the market again. So this gives them the confidence in the Indian market, or wherever the co-processing is termed as an important policy by the government is given upon. Yes, it lowers the ecological footprint of the industries also. It will reduce the CO2, conserves the non-renewable sources of energy. It reduces the pressure on them for the reduction, and to reduce the environmental impacts. So the three main parts we would like to show that in any economy, any life cycle is economy, environment, and the society. Sorry. Is the society. So economy is cost effective, environment is to reduce the CO2 emissions, society is the cleaner community, no landfilling, no orders. So bringing all the three together, it will what is important is the sustainable waste management solutions, which needs to be given to the from the industry by the government or by the industries which they are putting upon. So what co-processing strategy we adopt is the sustainable operations, like CO2 emissions is reducing. We create a value for our business. Already the available assets we have been utilizing it for the co-processing of waste, for the prepare. The important thing is the flexibility. The equipment what we select for pre-treatment should be flexible enough to cope up with the material availability in the market, the waste available in the market, to produce them to the green fuels. If only we design the system only for the plastic and we get the other material, then we will be again have to do the investment. So flexibility is a key for any co-processing of waste. We should have the dedicated structure, like dedicated workforce for maximizing the co-processing, the transportation, the feeding systems, everything has to be dedicated. No separate for cement and for the pre-processing of the waste. And of course, yes, there are benefits. We are reducing the green fuel, we are reducing the production, which gives the benefit to the service and conserving the energy. The clear advantage, like earlier also said, so just keep it like it avoids the formation of dioxins and furans due to the higher temperature what we have. There is no residual left when we burn any of the AFRs. Whatever ash coming out of the burning, it mixes with the clinker with our product and comes out as a product. There is no separate ash generation. So this is how it would preserves the fossil fuels and primary raw materials. The challenges for the co-processing what we face is the permitting procedures or the interstate transport of the hazardous waste. And during the pandemic, it was the interstate movement was restriction because of the risk of the COVID transferring from one state to other state. So everything was restricted. So this was the challenge. Changing handling properties of the waste arriving. So like cement industries are maintaining the quality parameters by utilizing the waste what way they can get it accordingly they are doing. But it also should come from the waste generators, where they send the waste as per the service level agreements made, so that it will be co-processed in the safe manner. It should not happen that when we open any of the drums, any of the material, there is surprise coming out, or there's explosion or the fumes coming out of it. The third point is the acceptance of the local community for utilization of waste. Due to orders, and everyone will think that why to bring the other state waste into our state. So due to COVID, this community was restricting. So what we are doing is the sanitizing of the vehicles, which is coming out and also going out of our plants. Parameters check for the drivers are done regularly, and also the record keeping of the things. Utilization of fresh MSW or the RDF only after 3 days, because it was said that after 2 or 3 days the COVID or the coronavirus gets destroyed. So it is planned accordingly that only after 3 days of loading, the material is unloaded at our site and it is being consumed. And the important part is that availability of reliable indigenous equipments for pre-processing. All the industries or all the cement industries, what they're having it is the imported parts. We have been trying with the Indian equipments for pre-processing for size reduction, but we were not getting the enough reduction in size. Also, the output was less. So this is also a key challenge, where the indigenous equipment can be used for pre-processing of the waste, and thereby supporting the circular economy and serving to the society. Namaste. So this is all. In short, I would like to present myself. Thank you.
Thank you, Mr. Patel. So we have come at the end of the session. It has already been requested to put the questions in chat box. So, and we are running a bit behind time also. So I hope that that the technical lectures had been enlightening for all of us. And with permission of Professor Sadhan Ghosh.
Yeah, Dipankar, there are 1 or 2 questions I have seen. So it is in your WhatsApp box, or I'll request the person who is raising the question, please come up.
Yeah,
I have seen one question. Please go ahead with the question answer. For next 10 minutes, we can spend question answer and chair summary.
Sir, should I ask the questions?
Yeah, please, please.
This is Anna. Okay, first question from Arshanindu Mondal sir from Facebook Live to Mr. Chaudhary that please comment whether the following three industrial solid waste, rice husk waste, red mud and clarified sludge of steel plant can be used in co-processor of cement plants. This question is for Mr. Chaudhary, JK Cement.
Yeah, this is well said. This all type of waste I already told. This can be used as an alternative raw material as well as a fuel. So there is no issue. For steel plant slag, we are already utilizing fly ash. We are utilizing from power plant. So this can be acceptable, and there is no issue. Already we are using, and we can use. No issue.
Yeah, thank you, thank you.
Okay, thank
The
you,
next
sir.
question.
Another question from Tejoshi Rana to Uma Shankar Chaudhary said that what step in your industry have taken towards using on non-recyclable plastic in cement kiln? How you manage the collection, segregation, and pre-treatment processes for non-recyclable plastic waste?
Yeah, this is for both, for Patel and Chaudhary, whether they were using non-recyclable. Yeah.
Patel, you are online? Patelji, if you are telling otherwise, I can take cover.
You can go ahead, sir.
Yeah. So this non-resize, this is I told in the presentation regarding the required all MSW should come through the pre-processing. That is that there is shredder, there is the augment. So inert as well as a stone material, everything can be out. Then only it can be acceptable. That is I have mentioned less than recyclable means recyclable material can be used, but should be the calorific value more than 2000. Moisture content is as lesser as possible, as content as lesser as possible. So this can be best suitable for the cement plant. So all inert, all stone, all muddy material can be removed, and this can be recycled in a cement plant. That can be best. As already our Patel has mentioned, there is a size is the limit. So this can be constant, and our production is also going to reduce. So we have to take care when we are taking for this material. But yes, if we having a shredder, we can take all municipal waste and we can shred and then we can utilize.
Okay, and thank you, sir. Another question to all the dignitaries that for utilization the waste for fuel in cement plant, who will has a tipping fee for waste treatment?
Anybody, maybe the generator can collect, maybe third party has to give. Generally, there is a concept, polluter has to pay. So if polluter, that is maybe this is a municipality, there is industry, so he has to pay. Polluter has to the pay. So that can be, this is the all material can be co-processed as a in a cement industry. So cement industry is having the capacity to utilize, but polluter has to, because cement industry having the major challenge during the segregation, collection and the utilization, because this is a major concern about the process plant operation as well as the quality. Yes, polluter has to pay.
Okay, thank you, sir.
Thank you. What I'll request you to keep this question and hand over to the chair and co-chair, because we have lots of time. So let them summarize and conclude this session. Chair and co-chair, please.
Thank you, Professor Ghosh. I would like to thank very much to the presenters. So in this session, we have heard about the presentation from both India and Vietnam. So from India, we learn a lot from the national picture of the circular economy by Professor Ghosh, and also circular economy in some sector like steel, cement, and other sector, which are very good practices for Vietnam. From Vietnam, we have heard also national circular economy from both Professor Hai and Mr. Dr. Nam on different aspects. So, and we also heard about the question from the audience about different issue in the cement and the steel sector. So from our side, we would like to thank you very much interesting and useful information and knowledge from the Indian presenters on this circular economy. Thank you very much.
Thank you. The different presentations that we have experienced were very rewarding. We learned a lot. The technological steps which are being taken and which are to be taken regarding energy minimization and consumption minimization have been mentioned. We have heard about effective recycling of wastes, and as I was telling that in densely populated countries like India, where construction of high-rise buildings is a must, we have heard about the effective steps taken by the steel and cement industry. And we have also heard from our Vietnamese friend that how he has clearly indicated that technological steps are okay, but appropriate legislations and awareness is the key to success. And we have also seen, what are the general steps which are to be taken and what are the special steps which are being taken from different angles in the perspective of present COVID situation. I want to convey my sincere thanks to all speakers, to Professor Sadhan Ghosh and everybody here. Good afternoon to everybody. And I would like to move on to the next session. Thank you very much.
I would like also, on behalf of the two co-chairs, to express our sincere thanks to Mr. Mohanty from UNCRD for his very comprehensive presentation on the TRIA forums, on international agendas on circular economy, and especially on those very comprehensive and specific measures, as he mentioned in his presentation, to promote the to a circular economy, including institutional arrangement, governance, technology, partnership, and especially important is the industry 4.0, which provide more opportunity for us to promote the circular economy in the context of the COVID-19. Thank you very much, Mr. Mohanty.
Thank you, Dr. Pan.
Thank you.
Thank you very much,
Thank you,
Professor Ghosh. Now we would like to move to the panel discussion, and I would like to give the chair to the Professor Ghosh.
Thank you. Thank you. I now request Professor Amitabha Gupta. Amitabha Gupta, you are here. Amitabha.
I have just unmuted my mic and I'm very much there.
Excellent. So me and Amitabha, we are both colleagues in Jadavpur University. We will be conducting this panel session. Before I start, I request our organizer to introduce Professor Amitabha Gupta. Please.
I request Oraya to kindly introduce Professor Amitabha Gupta.
Dr. Amitabha Gupta is presently a professor in the Department of Power Engineering and the director of the School of Nuclear Studies and Applications at Jadavpur University. He served at the Nuclear Power Corporation of India and the Center for Development of Advanced Computing, where he was actively involved in the design of computer-based systems development of real-time systems. A recipient of the DAD, German Academic Exchange Service Fellowship, Professor Gupta has served as visiting scientist and visiting professors for multiple terms at the Technical University of Munich, the University of Bremen, and the University of Rostock in Germany. He is presently a research ambassador of DAD in India, a member of CII's task force on startups, and president of the institution's Innovative Council of Jadavpur University, an author of number of well-cited journal and conference papers and books, book chapters. Professor Gupta is actively involved in research in the domains of control, automation, and engineering application involving real-time signals and systems. Thank you. I hand over to Professor Ghosh.
Thank you. Thank you. Now I request our organizers one by one to please introduce our panelists. We have 5 panelists: Dr. H.N. Chanakya, Dr. To Kim An, Professor Van Din Son Tho, and Associate Professor Trans Van Huang, and Mr. Umashankar Chowdhury. So I request one by one, please introduce them quickly. Then we'll start the panel discussion.
It's my turn to introduce Dr. Chanakya, the Chief Scientist of Indian Institute of Science, Bangalore, India. He has had 50 publications and experts in the area of biological waste management. He extensively worked on high-rate biomethanation and patented 2 high-rate biomethanation technology for the treatment of organic solid waste. He was awarded with Icon SWM Lifetime Achievement Awards 2019 by ISWMAW. He working committee constituted by Government of India, and now he is a member of Planning Board of Karnataka Government.
Thank you, Kwang.
Okay. So I would like to introduce next panelist, Dr. To Kim An, who obtained his bachelor degree in food technology from HUST Vietnam in 1982 and PhD in biotechnology from same university in 2000. She is an associate professor at Faculty of Biochemistry, HUST Vietnam from 2005. Dr. To Kim An is an author and co-author of several books and numerous research papers published on domestic and international journals. Her research interest is in the area of microbial enzyme, lignocellulose, biorefinery, and biofuel from biomass molecular diagnosis. I will also like to introduce the next panelist, that is Professor Van Din Son Tho, who obtained his PhD from Hanoi University of Science and University in 2005. He worked as a lecturer of School of Chemical Engineering, HUST Vietnam, from 2007 to 2011. Currently, he is an assistant professor at School of Chemical Engineering, HUST Vietnam. Professor Son Tho is an author, co-author of several books, several research projects, and numerous research papers published on domestic and international journals and conference proceedings. He is a leading expert on thermochemical process and biomass at Hanoi University of Science and Technology, with 15 years practical experience in biomass energy processes. His area of expertise include conversion of biomass, waste for heat and power generation, biomass combustion, gasification, pyrolysis, etc. Yeah, so I will like to introduce again the next panelist, that is Associate Professor Tran Van Quang. He is the Vice Director of Environmental Protection Research Center, Da Nang University of Science and Technology. The University of Da Nang, he obtained his engineering degree from Technical University of Bratislava, Slovakia in 1987 and a PhD in National University of Civil Vietnam in 2004. Since 1990 to present, he has been a lecturer in the of Environmental Engineering DUT, and in the past 10 years his research interests are wastewater treatment and solid waste management. So thank you.
Thank you. And Umashankar was introduced earlier. So now let us come back to the business, and now it's 3:44 in India. We will pack up the panel discussion by 4:30 and then the concluding remarks. So you know that I believe that Patel is also there from Dalmia Cement, then it will be helpful. Mr. Patel and Mr. CRC Mohanty, I can see CRC Mohanty, and if Patel is there, then it will be good for the panel discussion. So you know that in the panel discussion, both of us, me and Professor Amitabha Gupta, we have discussed, and we will take up mainly the three issues in this panel discussion. One is the ISWMAW for a long time has been mentoring and also trying to make people aware that unless and otherwise the waste management becomes a business model in each of the countries, it is not possible to sustain. And then only if the waste management is converted into the business model, effective business model, then only we can see the circular economy implementation. This is one. Second thing, there are number of actions because in India and Vietnam, we know that dumping is a very popular word and we like the word dumping because we like to dump the waste which we are generating. But on the other hand, for the last couple of years, at least 1 or 1.5 decades, both the countries are also having different actions to stop dumping and again converting those materials which are being dumped earlier are to be converted into some useful material. So this is the second area. And the third area, and how the reducing dumping and increasing the resource efficiency in both Vietnam and India we are taking. The third is specifically on co-processing, because you know that we in India and I personally trying to encourage the co-processing of waste in cement plant. We have in a committee in ministry made a norm on standardization of the RDF to be used in co-processing, and we are also trying to make a generalized business model in India so that co-processing is more than any other waste treatment process. So in that way, TSR is one of the very important issues for cement plants using co-processing. So how we have taken a target of 25% of TSR in long in long run, not in long run, in very short time. So how this can be achieved? These three are the points which we will discuss in this panel discussion. So first, let us open up with how in India and in Vietnam, people and the government are trying to make SWM as a business model. So if I go to first Van D. Shaw Stowe, please, you take 2 minutes time and let us know.
Vietnam forbidden to landfilling, dumping, and waste incineration is become popular in Vietnam. In order to convert to electricity or heat, it needs a high investment and a very large capacity, 500 tons per day. So currently, Vietnam will focus on the incineration without heat utilization. As a capacity around 200 tons per day. Yes. So for considering producing RDF, the quality of the waste is too low. In order to get the RDF, the quality should be improved by pre-treatment and recycling or bio-drying and so on. Another point here is that Vietnam didn't have a regulation or specification of the RDF. So people don't know what is RDF. RDF is still a waste or it's a fuel. So if we didn't define it is a waste or the fuel, the cement plant can't using it. And second point here, who will have tipping fees, for example, $100 per tipping fees. RDF production got a fees or the cement plant had a fees. Yeah, so here is not clearly relating to the regulation of the government. There are no discussion about the tipping fee, and many things should be considered in order to improve the quality and in order to utilization the RDF due as a fuel. And another
All right.
point
Thank you.
is the waste treatment. So if you burning RDF, flue gas treatment will be considered, because now you coal with a low chloride content, but if you do RDF, chloride content very high. So the waste treatment, flue gas treatment should be considered. So it's some point we want to mention, in my opinion, about the situation in Vietnam. Thank you.
Thank you, Professor. So, yeah. Meantime, I'll request my co-chair to make a chair summary at the end of this session. So he will be noting it down, your points and other things. So in that way, I'll request now Dr. Chanakya on this issue, how the SWM is converted into business model in India. Chanakya.
Thank you. Are you able to copy?
Yeah, please.
Thank you. Thank you, Professor Sadhan Ghosh and everybody else. Yeah, what is now being done at various cities in India, and especially where I am particularly very closely involved with the City Corporation of Bangalore. One, we have had difficult experiences with trying to create a tipping fee. So the business model will be into future without tipping fee. So the second issue is that when we have started collecting segregated waste over the last few years, waste is going very fresh to the from collection, and it has very high moisture content. So the technical options that we have today is only biomethanation and value-added products from there. And the dry waste being collected separately is now also being value-added into various, it's going back to recycling. And most interesting and most recent one we have found is that once they separate the plastics of different kind, they're able to make boards and furniture. So this is where a lot of startups are coming up within the city of Bangalore, and the government is also having an open policy saying that anybody who has these kind of technologies are free to come and set up these plants. So most of the dry wastes are getting into recycling, especially plastics, paper, and wet waste. We still have a problem with wet waste because our biomethanation plants have not met the requirement. But as a policy measure, the government has announced that it will buy purified biogas, which is called compressed biogas, 92% plus methane in the gas. If you can purify gas, it will purchase it at Indian rupees 50, in the range of 50 rupees or to 52 rupees, depending on where you're going to supply. Now, this is making it a very economic proposition, because every time you're able to produce 5 tons or more, the oil marketing companies will come to your doorstep and purchase. These kind of waste now have begun waste processing to compressed biogas, and consequently being injected into our compressed natural gas lines is becoming very popular, and we are seeing at least 26 large industries which are capable of producing, which are capable of using anywhere between 100 to 1,000 tons per day emerging on the agro waste side. And about in the 100 to 200 tons, a lot of people are showing interest in the municipal solid waste side. So once these come up, we have very little problems with the, likely to have very little problems with the solid waste, except the fact that upfront at the ground, the consumers are not in a position to give 100% segregation. So we need to go a little extra mile to make sure of that. Thank you.
Sure. Thank you. Now I like to request Dr. To Kim An, if you have any point on this, the business model in Vietnam. To Kim An?
Yeah, so actually for the CEs, the business established for the CE context in Vietnam, I think that it's one of they may be established like some like kind like circulate, no, not that circulate, reuse better the the biomass. But for the fully approaching as a CE, I do not think that it's already set in Vietnam. My major is on my interest on the biomass, and I can see from biomass point of that, so they can exploit some value still there in the biomass on the like a byproduct of the production, either for agriculture or either for food industry, etc. But that is still kind of like additional, not a compulsory, and also the not that a very, how to say, excellent example to be present, because all of that is still in the investigation state, I think.
Yeah.
So
Thank you. Thank you.
we still need, yeah.
No, it's all right. I
Okay.
got it. Because you know that in Vietnam, there are a number of biorefineries which are either in experimentation stage or in implementation stage. And with respect to the circular economy implementation is concerned, we don't expect significantly very high level activities in developing countries. But we want, our motto is to initiate different types of activities, whether it is a small, medium, or bigger, in different countries, so that conglomeration of different small activities towards circular economy can make the country a resilient and resource efficient. So that's why it's not the point whether it is very small or very big, but the point is whether it has been initiated or not, and whether it has been understood by or not. That is more important. Thank you very much. I am not coming to Mr. Chaudhary and Patel now, because I'll take up with them some other issue which is really a business model with respect to the waste management is concerned later. Yeah, this you know that we have a specific business model in India, and as I was telling that we are focusing much on, one is the bio methanation or biogas plant, which Dr. Chanakya told. Like we have number of examples, say 20 tons, 10 tons of biomethanation, and the gas is generated, and that gas is transported for the movement of bus. Like in Indore, my friend Mohanty was there with me in Indore. We have witnessed that the gases produced from the biogas plant, that is given taken by the buses, public vehicle, and the public vehicle is plying with those gases. So in that way, this is also a business model. So there are a number of business. If Mr. Mohanty can remember, I'll just request Mr. Mohanty to share.
All of us visited and witnessed, the public buses are running, from the gas generated by the biogas plants, as you correctly said. I think this is waste to energy economic model, I would say. So, but I don't know actually what is the percentage of the public transportation system covered by, this biogas, whether there is, the small scale application. I don't remember exactly the extent of use of biogas in public transportation system in India, but they have at least, they have started using it.
Sure, sure. That's good. Thank you. So you know that that plant is 20 metric ton per day. They are producing biogas out of those mainly market pairs. But there are small examples of very small, like say from biogas, the street lights are burning. The kitchen is operated by biogas. In Bangalore, there was a initiation of 200 tons per day of waste for biogas plant, but it was stalled for some time, and maybe we are expecting in some more time it will take to revive the plant itself. So in that way, there are initiation of this process in India. So the second thing which I was referring to, that co-processing of waste, that's a very important aspect in India now, and I will try so that the Vietnam can also take up this issue with the government, that RDF and also co-processing of the cement plant. That's a very very effective business model for waste management. So now I'll come back to Chaudhary ji and Patel. First, you utilize TSR. This is one of my research area, and my scholar who has done PhD on this co-processing is sitting here, Rahul. So I'll request you to please explain what is TSR, because most of the people don't know TSR. And then we have set a target of 25% from 10 to 12%. What is the action plans you have planned in your plant and also in Palmia? Please.
Yeah. Mr. Patel is here, so can I proceed or Ghosh ji?
Patel, Mr. Patel, you are here? Okay, you go ahead. Let him come.
Yeah, you are rightly pointed out about TSR, and this is your subject for the analysis. This is good because during the co-processing, yes, if you will talk about the one thing, so one KPI, that is the key performance indicator, is the TSR, and how TSR is being calculated. That means if at present we are doing our production level 7,000 ton per day clinker production. So for 7,000 day, if good quality of fuel is available, that I can say the pet coke. So pet coke having GCV is around 8,000. That is a GCV, gross calorific value. So if we are utilizing this, so that coal consumption will be around 8 to 10% for the production of the clinker. 8 to 10% of the fuel is required. So when 8 to 10% coal consumption, that means 7,000 to 10%, that is 700 fuel is required. And 700 fuel if having the GCV around 8,000. So this much kilocalorie is required to produce the clinker. So TSR means thermal substitution rate. So how much you can substitute the main fuel to the alternative fuel. And as you are talking about the MSW, we are not talking about the MSW. You are rightly said, I think, for the Vietnam, we have to go for the RDF, that is residual derived fuel. So RDF is a product of MSW after segregation, after pre-treatment. The getting is the RDF. And when we are talking about RDF, this is the after pre-processing, that is this is straw meal, after straw meal, so all inert, all stone, everything moisture, muddy, compost, everything removed. Then what is the material is remaining, that is RDF. And generally, RDF chemical composition is this GCV around 4,000 kilocalorie. Moisture content is around 15 to 20%. As is around 15 to 60%. So when we compare pet coke having the 8,000 kilocalorie and RDF having the 4,000, so you having 50% kilocalorie. So for substitution 1 kilocalorie of the 1 kg of pet coke, you require 2 kg of the RDF. But we are talking GCV. Of GCV, this will go to the NCV, that is a net calorific value. The net calorific value will come around 2,500, because if moisture is 20%, that means 20% will go on. After 4,000, 20% again gone. So what much the remaining, that is the NCV, net calorific value. Because when we are feeding RDF, this is going with the RDF with the moisture in the system. So again 20% will go out. So that means around 3,000 NCV will remain. So how much pet coke or any main fuel will be substituted by the alternative fuel, and this is the being calculated how much gross NCV we have replaced from the main fuel to the AFR. So if we have used around daily basis, I have shown you our plant having the automatic facility, that is we are feeding around 15 TPS. So 15 TPS in the 24 hour, this is not possible 24 hours. So 20 hours, 310. So 310 we are replacing this AFR by the 100 ton of the pet coke. So by the gross kilo, how much kilocalorie has been substituted? So that will come around 15% TSR. This is the TSR, that is thermal substitution rate. How much, as not for the volume, I am not talking about the volume, because how much kilocalorie NCB will be replaced by the fuel, that is alternative fuel. So this is TSR. So when we are starting, we have a start around daily only 1 TPS, so 50 ton, 100 ton only we are. Now at present we are doing around 300 to 400 alternative fuel ton per day. So this is replacing around 15% TSR, that is 50% thermal substitution. So this is the TSR, and we are focusing for the right kind of effort. So after pre-processing, we are focusing moisture reduction, chloride is the big part. So this is the TSR, and then this will help for the co-processing in the cement plant. So this will not affect of the plant operation, plant problem. So clinker production will be the continue. I hope I have clarified about the.
Yeah. Now you tell us, what is the business?
Yeah, definitely, as I told regarding polluter to pay, because this even you can say this is Goa model. In India, the very good one concept Goa government has been started. Goa government is doing the all collection and segregation. He has given to third party for the segregation, and after he also, as you have rightly pointed out regarding the biogas. So he is the with the AFR, with the MSW, he is producing the power also. I think 5 kilowatt or something. He is generating the power with the RGF, with the AFR, and he is providing to the nearby. We are nearby, around 200-250 kilometers away from the Goa. Our plant is situated. So right kind of fuel we are getting from the Goa. So Goa model is the best model for the business. He is giving the some transportation, because transportation is we have to use. So there is several problem coming in the pre-processing, co-processing plant. So Goa is giving at the landed cost at the zero. So he is sending the waste with the after pre-treatment. So this is the model, and this model can be adopted by the all other government or all other this stakeholder, all other, that is the middle management version. And there is the government already has at 2016 there is a job, that is a stage 1, a stage 2, a stage 3, that is the RDF category 1, 2, 3. So this type of A grade category or B grade can be supplied to the cement plant. There is no hesitation of any of the cement plant can utilize A grade or B grade RDF. That having there is a chemical composition. So this model can be adopted by the all, and this will be the best model for the cement win-win situation for the MS, that is a municipality, as a municipality, or the generator as well as the cement industry.
Thank you. And I believe that in the technical session there was a question by one participant regarding the tipping fee. So this is one of the example of tipping fee in the cement plant. And by giving tipping fee also, the industry can make a very good business out of the waste. So in that way, Vietnam can look into it, that unless and otherwise waste management is converted into a business model, waste management will be end up with the dumping only. So in India, it is a transition period, and we are quite sure that in near future, we can make the dumping yard at least reduced by 20 to 30%, if not more. So thank you very much. So now I like to know whether Professor Tran Van Quang is here or not.
Okay.
In the panel. You
okay,
are here.
I'm here. Okay.
Yeah.
Okay, thank you for
remembering.
Okay.
Yeah, please let us know what is the business model existing in Vietnam with respect to the waste management. Any small, any big, any case study.
Okay. Thank you. As you know, in Vietnam, at this moment, is similar in the so that's India for municipal solid waste management. But on this moment, I am from Da Nang. Yeah, so now in a small city, maybe 1 million people. On this moment, we have to one challenge. We want to try to separate organic matter from municipal solid waste. We have to weigh the first way we want to convert to biogas with some support from Europe. To second, we want to try to composting. Yeah, as now and two way, it may be too high cost. According to your thinking and according to your experience in India, Professor Ghosh, could you share me how about to advantage and unadvantage and maybe to barrier constraint when we want to separate biosolid to convert to biogas or compost? How some business model in India?
Yeah. We have adopted. You know that the basic problem of waste management is the waste are not segregated at source. And this is not only in your country, this is in most of the countries, specifically away from, if you go away from the developed countries, this is the main issue. And as the waste are mixed, not segregated at the source, all the problems comes at the end. So the first and foremost thing, you have to install a system of waste segregation at source. So this is another topic in our panel discussion. Let us hear what is happening in Japan. That will be learning for all of us. So I request Mr. Mohanty to say on what is happening in Japan, the waste segregation.
See, the most fundamental thing that is driving 3R or the waste management as an economic industry in Japan is fundamental law on establishing sound material cycle society. You see, the municipalities governance system has the citizens' behavior is also greatly influenced. The industry sector is also streamlined, and there are a lot of laws and regulations that are in place to drive the 3R and the waste management as an economic industry. If you know, Japan is a country which has been promoted actually the concept of eco city. You know, the Kawasaki city, Kitakyushu, and many other cities are known as the eco city. And if you look at the footprint of these eco cities, you will find a systematic relationship between the three actors: the government, the R&D sector, the research and scientific organizations, and the private and corporate sector. This is what the triangular cooperation I talked about. And the epicenter of this triangular cooperation is actually the citizens' behavior. Here in Japan, you can see our culture. You can see the people, the citizens, the school children, they take part in waste segregation, the household waste segregation activities. You know, that actually drives the process of waste as an economic industry. It is not only the municipality job here that is supposed to do is believed to, you know, the waste segregation. Actually, people, very much the citizens take part in the waste. So in a way, I would say here, the most fundamental concept that is driving the waste segregation or waste, the resource recovery, or the waste as a business industry is city support business and the business support city. You know, there is a symbiotic relationship between city and the business.
Sure.
I was hearing just before, you know, the various business models in India. Definitely, you know, as Professor Ghosh rightly said, India actually is in a transition phase to get into very systematic, you know, waste management into the economic industry. That is because these pockets of excellences are actually not scaled up throughout the country, whether it is a biomethanation, whether it is a RDF, waste to energy, any sort of this three circular economic models are not yet actually scaled up throughout the country. And another thing is that here you can find also the policies, the regulations also very conducive for public-private partnership. And that's why fundamentally the waste is seen as a resources that drive the whole waste management as an economic industry. For example, if you see the packaging, the packaging, whether it is a packaging material for electronic product or any other thing, there is a systematic law and regulations are in place to recycle all the packaging materials. There is also high recovery rate for the aluminum cans or any other plastics bottles. That is because there are systematic collection points and people take part, and industries the government provides the umbrella, policy and legislation is sound material. Japan.
Professor Tho, do you have any initiative in the country to segregate the waste at source? If it is, what is that?
So from the discussion, you talking about the biogas generation and the RDF production. So in order to get the biogas or RDF, you have very carefully a separation process. So in Vietnam, because the quality of the waste is very low, so cannot be generate methane, because we didn't get a food waste here, only cellulose. Biomass is only cellulose. A lot of the company thinking they can generate biogas from the municipal waste, but cannot, because if there are a food waste, you can generate the biogas. But in fact, it only biomass, and the main composition is a cellulose. There are no biogas information. Furthermore, in order to get biogas, you use a lot of water. So it means it's not a feasibility to get the biogas if you try to focus on the municipal waste in case of the Vietnam. And in Vietnam, we didn't produce art yet because currently we have no regulation for qualification of the RDF. But people still separation to get the plastic, to get the paper to recycle by themselves. So everything can be recycled were done by the waste treatment. For example, plastic, everything they get it and recycling. And another thing, they can put to the incineration. For the composting, a lot of 5 years ago, every waste treatment prefer to get the composting. But now all of these will fail because nobody using this kind of compost because the quality is very low. And a lot of because there are no organic component here, so no way to get the compost if using the municipal waste to convert to the compost. So till now, only plastic were recovered and recycled using the separation process. Biogas is not a feasibility, and compost, nobody consuming it. So it's a practical case.
Thank you.
Thank you.
All right, thank you. I request Kim An. You know that if you need to recycle plastic, then how do you get plastics if your waste is mixed at source? Do you separate your plastics and other material, dry material at source, or not?
The current situations for waste, in Vietnam include also for the domestic, mean that we do not separate the baggage that you say. So
Okay.
the mix up with, I mean that for the organics with the plastic, it's the thing that really can be recycled, and the other also for the construction baggage, everything in one. But we also have some kind like a business to produce bio fertilizer from the waste. So in that so-called factory, so they have to have some kind like a machine to blow up the plastic out of the other waste. So that also cannot separate the very, how to say, small fragment of the plastic. So that mean that in the fertilizer.
I understand.
Yeah.
Do you adopt the bean culture at home?
I can tell you, even the people. No, we have so many plants since I remember. We have so many plants since 3 or something, and if you have this, even so, but I think the organization is not so good because even you have the separate bin inside the family, so that one side will put outside to be collected, every in one. So nothing happens. So I think that the main thing that I do not understand why the waste cannot be separated successfully.
That's the main concern, and we have to. I mean, in Vietnam at least, you have to do two things. One is the source separation of waste, and the second thing you have to encourage RDF making. So this, if you can implement these two, then there can be a very good business model which can be generated out of waste. So I like to request Professor Gupta, the co-chair of this session, if he has any question to the panelists.
I actually have an observation.
Excuse
Not
me,
really a question.
Professor Ghosh. Did you hear me?
Let Professor Gupta say, and then you come back. I'll come back to you. Let Professor Gupta say something. Please, Gupta.
Oh, okay. So as I was just saying, that I have an observation, and this model of solid waste management, a business rule based on solid waste management and also co-processing, and particularly in terms of thermal substitution ratio, exists for a long time in the industry with which I started my career. That's the nuclear industry. As you might be knowing, that in India, the nuclear fuel cycle is a closed cycle and nothing is wasted.
Yeah.
So basically, so we have a business model which thrives on solid waste management in a big way. And secondly, I would also like to point out that the concept of processing is also a very old concept used by the nuclear industry. For example, I don't know how many of you know about desalination plants and the production of hydrogens actually. So in Saudi Arabia, they tried. I mean, they tried with the technology is like this: you produce a huge amount of nuclear heat, and that nuclear heat goes on to produce steam, and then ultimately high temperature electrolysis of the steam produce your hydrogen. And at the same time, you also desalinate a lot of water, because the water also has to be actually boiled to produce steam, and therefore the effective TSR is very high. And this has been a model which has been existing and has been working for quite some time. And I believe that the crux of the story is necessity is the mother of invention.
Sure.
Yeah.
Sure. Thank you. Thank you. Yeah, Professor Hai, you wanted to say something, please. Professor Hai, over to Professor Hai.
Yes, thank you. Thank you very much for giving me a few seconds to talk about the separation of the waste according to my experiences. So I would like to talk about the plastic waste separation. Firstly, at home, the plastic waste separated at home. And when the municipal solid waste go to the dumping site or go to the designated place for collection, the workers who work in the municipal solid waste collection company also collect plastic from the solid waste. And when the municipal solid waste go to the dumping site, another the third collection of the plastic waste again, and the management of the dumping site will be buy that plastic waste from dumping site from the waste picker, waste scavenger, and they will separate due to the quality of, for example, the BE or BB or something like that, or it's known for recyclable and non-recyclable plastic waste. And recyclable plastic waste will be go to the recycling process, and non-recyclable plastic waste will go to the RDF. That is my experiences about that, and I saw that process in the Hanoi. So I would like to share some experiences in the business model for the plastic waste, from plastic waste to the plastic, and plastic waste to the energy. Thank you very much for your attention.
Thank you. Yeah, it's right, because I have seen in Hanoi there are a number of places where there is no plastics on the road and other things. So littering in many of the places is not seen. However, the last 2 points we will take up. One is Dr. Thang has a question that why in 2017 and 18 the number of cities in India has raised to a greater extent in implementation of circular economy and etc. etc. You know
Yeah,
that
10 times.
yeah. So you know that why we have taken a mission, Swachh Bharat mission in 2014, and as I showed in my slide that we started with only 76 cities, and our target was to include nearly 4,034 cities in this process. So in that way, the number of, once some of the cities are involved, they get some award, then again more number of cities were involved. So in that way, in succession from 16, 17, 18, 19, 20, we could achieve a target of 4,242 instead of 4,034 cities. So that is because of the encouragement, because of the governance, and because of support from the government, it could be possible. And in 2021, we are giving different types of award to the cities, and we are sure that, of course, the pandemic has given us a stop for some time, but we are sure that it will not stop for a long time. And in 2021, we can achieve a lot beyond 4,242 cities. So the last point, which I'll come to Dr. Chanakya, because you know that we are not only taking the municipal waste, we are also taking the sewage sludge for utilization for different, mainly energy or other products. So I request Professor Chanakya to give some light on this, what is happening in Bangalore and other cities.
Okay, thank you, Professor Ghosh. Audible, no, this time?
Yeah, go ahead.
Thank you.
Go ahead.
Bangalore has been a very ambitious city that it draws in about 1,200 to 1,300 million liters of water from a river 100 kilometers away. And the cost of water is very, very high. So it has done, it has now attempted to treat this water very close to tertiary standards. The secondary treatment happens within the city of Bangalore, then it is pumped almost 100 kilometers away, 70 kilometers, and spread into 128 tanks. So about 400 million liters is now spread to a district called Kolar, which has been a chronic drought area. So now there are 3 valleys in Bangalore, and all these are now being recycled, and plans are being made. So this will be one of the world's largest sewage recycling systems that are coming up. And of course, the recycling system will not be a direct recycle. It will recharge the groundwater to make sure that what if there is something untreated, I'm saying again, if there's something left untreated or not handleable by the conventional wastewater treatment system, the soil system will make sure that it is completely converted and you draw it from groundwater. So roughly about plans, we are already on the job to do 400 million liters, and plans are there to do the other 800 million liters. So this will be one of the first and the largest one. Sludge is being anaerobically digested, and the gas is being used for producing electricity for internal uses and something back into the grid. And we have large anaerobic digesters which do this kind of digestion. So there is now reasonably good handle on how do we deal with wastewater. But the city grows faster, much faster than it doubles itself close to every decade. So the planning process and the ability to demonstrate it on the ground is a lag, and people are quite often unhappy about this. I see it from a larger perspective rather than from somebody on the ground saying that there's so much sewage not being also utilized. Thank you very much.
Thank you. This is one of the very new initiative which has been taken in India in different cities. The other initiative in India which we have taken is the FSTP, fecal sludge treatment plant, and in that Bhubaneswar, that is state of Odisha, is doing a very good job, and then other cities are just following them. The one more thing which I am highlighting for Vietnam cities, the segregation of waste at source, because you know that in Calcutta where I am staying, the ward number 115, I initiated a process in 2006, and in this ward around 4,200 households are living. We have appointed around 25 ladies who are poor, and they are collecting the waste from houses, each of the houses separately, twice a week for the dry waste and every day for the kitchen other waste, wet waste. And out of this dry waste, as you were the Professor Hai was saying about the plastic waste and others, this group of 25 ladies are collecting all the dry waste from the household twice a week, and we have made a material recovery facility where they are segregating again all the waste around 12 to 13 categories, and these are sold, and all these 25 people are getting some employment for a half-day employment in that particular material recovery facility. And such type of facilities are number of places in Bangalore, in Chennai, in Kerala, Mumbai, Maharashtra, and many other things. So that can be also a business model which can take up by Vietnam. So with this, I will end up with only the last one. I can see one of our friends, Dr. Shamla Mani. She is attending this conference webinar. I like to ask her if she has any point for this panel discussion. Dr. Shamla Mani. Yeah, all right. So maybe she has some problem. So with this, I really express my heartfelt gratitude to all the speakers, panelists, the speakers, and the chairs, Professor Dipankar Chakraborty and Dr. Tung Thang, my friend. Now I hand over this microphone to Professor Gupta, Amitabha Gupta, to please submit the chair summary of this panel discussion. Please.
Well, thank you, Professor Ghosh. And this has been a very enlightening.
Thank you.
And I would first like to thank all the panelists for taking part in this. And actually, as I said, that this is not really my forte, but nonetheless, I used it as a learning session to learn a lot of things. So the first and foremost thing that we discussed is basically the enabling concepts in solid waste management and what needs to be done. The legislations need to be in place. And I'd first start with Dr. Thor. Please forgive me if I don't pronounce your names correctly. I'm very sorry about that. I'll try to do that as well. So first, I'll discuss about Professor Thor, and I believe he talked about the problems in Vietnam. I believe he pointed out that it is mainly the lack of legislation that's a problem. And then we had Professor Chanakya, and his was perhaps the most enlightening of all. And I'm really delighted to know that Bangalore is going great guns about solid waste recycling. It is interesting to know that they have a problem, they have solved the problem in a very novel way, and they have emphasized on segregation of waste and mostly the weight waste. I mean, they use for biomethane generation, and I think it's pretty innovative to produce buyback schemes, where 92% pure methane is being sold back to the system. That's very interesting indeed. So Professor Kiman was asked to talk about the the mode in Vietnam, and what I gather from the panel is that there are several initiatives. Yeah. So I think it just went off.
Yeah.
Hello.
The microphone is giving. Yeah. Carry on. We can hear.
Can you hear me? Yeah.
Yeah.
So
Yeah. Now we can hear.
Yeah.
Please.
So there was so the next question that came is that we understood that in Vietnam, there is an emphasis on recycling solid waste. I mean, the plastic waste and waste which can be which can be recycled, plastic and paper, but not so much on wet waste because the quality of wet waste is rather poor and it doesn't need too much of biogas. That's what I understood. And there were several speakers who said, I believe Dr. Wang, Professor Wang was one of them, then Professor Tho again, Professor Kiman, etc. And so there was one very interesting deliberation by Professor Hai, about the model of solid waste segregation in Hanoi city, wherein the scavengers were being used. And this reminds me of something very similar that I saw in Germany long back. When you buy a PET bottle of Coke, let's say, you pay a fund. Fund means a deposit. So you can take all the bottles that you have, deposit it in one of these vending machines, and get back your money. So, and you can buy a Coke with it, with the money that you get back. That's very interesting. Maybe that is one model people can try for reducing plastic waste. And finally, it was Professor Chanakya again. I must not forget Mr. Mohanty, who actually explained the difference between a developed economy and a developing country. In Japan, for example, he pointed out rightly that the city helps business and the business of the city helps city. This symbiosis is yet to take off in countries like India and Vietnam, and when it does, it will be a wonderful thing. Mr. U.S. Chaudhary once again had a very nice and deliberation on what is. He used a very good example. At least I could understand what a thermal substitution ratio is. And then finally, we have one very interesting deliberation by once again by Dr. Chanakya, and he talked about the sewage waste treatment in Bangalore. Incidentally, I do remember something very similar, which I saw on a large scale in the city of Bremen way back in 1999. They had a sewage plant and they produced almost drinkable water there. And something once again in the year 2015, when I visited the Johnson Space Center in the USA. So they use the same thing on a much smaller scale in the International Space Station. So nonetheless, and it's drinkable. That's what they said. I didn't drink it though the recycled water. But it is very interesting to note from Mr. Chanakya that we have an indirect cycle also, where we just pump it into the ground and then after some time we take it back. That is also a very effective means, and it's very relevant for India, where there is a resistance to such things. On the whole, this has been a very enlightening session. I'd like to end this deliberation with a small note that the German Science Foundation had actually sponsored a large number of projects. They were centered around a theme called mega cities of tomorrow. Mega cities are cities with more than 3 million population, and these mega cities, most of these mega cities are going to spring up in Asia, and for such mega cities, water is a major problem. Waste management is also an equally big problem, and therefore, I believe that in this scenario, the topic of waste management is very important. Though I must add, on a lighter note, that the most important and the most, I should say, the nagging problem that we are facing with waste in the city of Calcutta is with a lot of COVID waste. We find a lot of masks lying here and there, and I wish we had a solution for this. Thank you once again for everything.
Thank you. Thank you. So now I request Dr. Thang. Before I go to Dr. Tung Thang, I like to share two experiences. In 2013, I went to Singapore and I drank the drinking water which was processed out of ETP, that is in Newater. They have a huge plant. This is one. And the second thing, in Germany, they are producing 10 megawatt of power in the co-generation, and a part of that was from the sewage sludge. So, however, over to Professor Tung Thang, Dr. Tung Thang, for a small concluding remark.
Thank you very much, Professor Ghosh. In Vietnam, we are facing a lot of issues for waste management, in particular, and circular economy in general. I think that one of the gaps that we identify is we still do not have the policy or regulation on the environment design, meaning that the circular economy, when we adopt that, we should take into consideration when we design the product for it easier reuse and recycling. So in our system, policy system, we still don't have that regulation, and I would like very much, Professor Ghosh, if you have, because in your presentation you mentioned about national design policy. So if you have that, yeah, please share with us. And
Sure.
our institute, yeah, okay.
Sure. Thank you. Professor, Mr. Mohanty, few words as a remarks. No microphone.
Thank you, Professor Ghosh. Yes, can you hear me?
Sure.
Okay, great. I'd just like to add, I think we discussed a lot of things. Once again, thanks to the organizers, your society in particular, and our colleagues from Vietnam. It is a wonderful webinar discussing many aspects of how we can actually promote circular economic industries in countries. I'd like to add a few notes that, achieving lasting supply security of natural resources is key to sustainable development. And the problem is that the many Asian countries have become net importer of the raw materials. So where actually the raw materials will come to meet the aspirations or meet the living standards of the Asian people. So this will depend how successfully we integrate actually circular economy in major development sectors, whether it is transport, energy, construction, building sector, agriculture, all these sectors. So my message is that we need to look into circular economy more in the context of a resource domain, natural resource domain, not within the waste domain itself. And because the way we manage our natural resources, it has huge implications towards waste generation, and also the way we manage our waste streams, that is the circular economic utilization of all waste, that will have profound implications on our natural resources and ecological assets. Our economic growth should not be at the expense of our natural resources and ecological assets. I think Professor Ghosh, I remember you are very rightly saying this: India is in the transition of moving towards circular economy, and also Vietnam in a transition to move more and more towards resource efficient or the circular economy. And some of the things that probably was not audible, I think you had mentioned. If you allow me, just very quickly say about the waste segregation in Japan. You see, the 3R has become a culture in Japan, where school children, ordinary citizen, housewives, everybody is part of the 3R process. People segregate waste at their house. You know, there are specific days designated for disposal of specific waste. For example, sorry. For example, your plastic waste can be disposed on Monday. The kitchen waste, the organic waste can be disposed on Tuesday. Your metals, for example, once in a month, glass once in a month, and your hazardous waste like batteries and dead batteries, etc., end of life batteries once in a month. And there are also the waste collection centers, like for example, most of the shops here collect actually the waste batteries, the end of life batteries. So this is, you know, if you dispose your kitchen waste on the day meant for plastic waste, the municipalities, you know, the collection system will not collect your waste. So that is why you see the life of the municipalities has become much easier because of the day-wise segregation and day-wise disposal of the waste, and actually that drives the resource recovery and the recycling rate in Japan. In addition to what I told, the city support business, business support Japan, sorry, business support cities, and where in a city you can find a systematic triangular cooperation between the governments, R&D sector and the private sector, and the people actually form the epicenter of this triangular cooperation. That means citizens are very much into the system, whereas in India, you see the people depend on the municipalities for waste collection, maybe segregation, recovery, etc. You know, informal sectors are working in India, I know, but we are not able to do this full scale utilization of the various waste stream for circular economic utilization. I have seen in India, you know, in some of the cities, people do segregate waste at their house and dispose, but at the end, the collection system, the municipal collection system, they put all the waste together. So actually,
Goes to dumping ground. Yeah.
it is defeating, you know, the very actions toward the circular economic development in India. I think changing. I think many of the good examples, you know, people are talking about the biogas utilization in public transportation system and RDF and various other things that is happening in. Certainly, these pockets of excellences are there in India, but it needs to be scaled up throughout the country. Otherwise, as you said, this dumping culture, Professor Ghosh, that it will continue to persist in India. Same thing probably, if you, Dr. Thang, if you agree with me, you have the, you know, various pockets of, you know, good practices, but it needs to be scaled up all throughout Vietnam to really drive the implementation of the Hanoi 3R declaration, very aspirational declarations in moving towards a circular economic society in Vietnam. Thank you so much.
Thank you, thank you, thank you. Now I give 1 minute to our industry partner, Chaudhary ji. Mr. Chaudhary. Yeah, from JK.
Yes, sir. I think we have already covered and nicely all presentation was very good, and this platform has given a tremendous you can say awareness about this present regarding circular economy for the whole world. I think this was the great you as you have starting you have given the total outlook about the total scenario as well as the all presenter has given the very good presentation, and we are also tried to give you about the cement industry and regarding the waste co-processing. So that was in totality that was the very great platform, and I am happy we are in the part of that platform. That was a very nice arrangement, nice coordination with the Indian and Vietnam as the member, all participant, all delegates. That even good. Thank you. Thanks a lot. Nothing to say.
Thank you. Thank you. I like to inform all the participants that JK Cement Muddapur, his unit, and Dalmia Cement Orissa, they received Icon Excellence Award for co-processing in 2019. So thank you.
Yes.
So the last part, I hand over to our administration, Dr. Pyle, to have some announcement, and that will be the end of the program. Pyle.
Thank you, sir. First of all, I thank ISWMAW for giving the platform to organize a wonderful webinar on the contemporary issue. I thank all the collaborating organizations for their support. I like to have few announcements. I cordially invite all the researchers, officials, experts, and scholars to submit articles to the 10th International Conference on Sustainable Waste Management towards Circular Economy, to be held during December 2 to 4 in 2020 at Kolkata, India. Submission date of full article is 30th October 2020, the details of which will be sent to you and available in www.iswmaw.com. We cordially invite you to register for joining the Icon SWM ASEAN and the Pacific Connect webinar to be held on 30th September, and the webinar on sustainable development and low carbon technology to be held on 15th October. With this, I want to add another thing. The certificate of this webinar, the certificate link of this webinar will be sent to you by 30th September. I hope you enjoyed the webinar. Hope to see you in the upcoming India Icon SWM Asia and the Pacific Connect webinar on 30th September. Thank you.
Thank you very much. So let us call it a day. And my Vietnamese friends are waiting for their dinner. It is already dinner time. Thank you. It was very
Yeah,
nice.
thank you very much, Professor Ghosh. Thank you very much, Mr. Mohanty, and all the Indian colleagues. Yeah.
Thank you. Thank you. Signing off.
And that whole
Thank you.
whole recording will be in the YouTube, and it will be shared with you.
Okay. Thank you.
Bye.
Thank you.
Bye-bye.
Thanks.
Goodbye.
Bye.
Thanks to all. Thanks to all. Okay.
Thank you all.
Thank you all.